satisfaction it brings you. That is what pushes me forward to do more.
Yeah, it has given me happiness and confidence. Like I have found myself, my passion for technology.
I just love colors. Every time I paint, I feel powerful. It is a form of expression for me, almost therapeutic. Here, I have always been encouraged to cultivate and harbor this artistic side of mine. And it's not just art, but music, dance, photography, and much more. Here, we get the space to explore all our passions.
College teaches you to see beyond your capabilities, to visualize the unthinkable and catch the unachievable. Life gives you certain opportunities to build your life, but college gives you the platform to live your life. Here, we share our memories, our stories, and our happiness. And it's a roller coaster of emotions. And before you know it, you'll realize that they have turned from friends into family. It isn't always about books, labs, and assignments. Academics are important, but there's definitely more to education than that. It's about finding yourself, about who you really are. It's about carving your own path. In this process of learning and growing, you build your own future. And then by the time it's all over, you realize that you're yet to explore so much more. What seems like the end is just a beginning. Come, find your beginning with us. When I first walked through the college gate, I never really knew what to expect. There was so much confusion and unfamiliarity. Yet, there was a certain sense of excitement, of experiencing something new, something different. Looking at these new faces, those smiles and chit chats, I knew my life is gonna change. Learning something new ignites a fire in us. Here, we are encouraged to think out of the box and understand concepts that are taught out of the class. We can sit together, discuss with our friends, and clear our concepts. This way, we can ignite this fire more and more daily.
For a young maker like myself, labs like these helped me start my journey into the world of technology. I fell in love with what I learned, and the sheer thrill of seeing the concepts come to life is just like nothing else.
I know. The things you learn while actually involving in the process and doing things for yourself helps you understand, connect the dots, and remember so much better. You know the feeling of making something with your own two hands? The joy and satisfaction it brings you. That is what pushes me forward to do more.
Yeah, it has given me happiness and confidence. Like I have found myself, my passion for technology.
Good evening, ladies and gentlemen. Let's give it 5 more minutes for everyone to join and then we will start the section. Also, we will initially turn off your mic and camera to avoid any disturbances. If you have any questions, please raise your hands. We will unmute your mic.
When I first walked through the college gate, I never really knew what to expect. There was so much confusion and unfamiliarity. Yet, there was a certain sense of excitement, of experiencing something new, something different. Looking at these new faces, those smiles and chit chats, I knew my life is gonna change. Learning something new ignites a fire in us. Here, we are encouraged to think out of the box and understand concepts that are taught out of the class. We can sit together, discuss with our friends, and clear our concepts. This way, we can ignite this fire more and more daily.
For a young maker like myself, labs like these helped me start my journey into the world of technology. I fell in love with what I learned, and the sheer thrill of seeing the concepts come to life is just like nothing else.
I know. The things you learn while actually involving in the process and doing things for yourself helps you understand, connect the dots, and remember so much better.
You know the feeling of making something with your own two hands? The joy and satisfaction it brings you. That is what pushes me forward to do more.
Yeah, it has given me happiness and confidence. Like I found myself, my passion for technology.
I just love colors. Every time I paint, I feel powerful. It is a form of expression for me, almost therapeutic. Here, I have always been encouraged to cultivate and harbor this artistic side of mine. And it's not just art, but music, dance, photography, and much more. Here, we get the space to explore all our passions.
College teaches you to see beyond your capabilities, to visualize the unthinkable and catch the unachievable. Life gives you certain opportunities to build your life, but college gives you the platform to live your life. Here, we share our memories, our stories, and our happiness. And it's a roller coaster of emotions. And before you know it, you'll realize that they have turned from friends into family. It isn't always about books, labs, and assignments. Academics are important, but there's definitely more to education than that. It's about finding yourself, about who you really are. It's about carving your own path. In this process of learning and growing, you build your own future. And then by the time it's all over, you realize that you're yet to explore so much more. What seems like the end is just a beginning. Come, find your beginning with us.
We are about to start the section. Let's just wait for one more minute.
When I first walked through the college gate, I never really knew what to expect. There was so much confusion and unfamiliarity. Yet, there was a certain sense of excitement, of experiencing something new, something different. Looking at these new faces, those smiles and chit chats, I knew my life is gonna change. Learning something new ignites a fire in us. Here, we are encouraged to think out of the box and understand concepts that are taught out of the class. We can sit together, discuss with our friends, and clear our concepts. This way, we can ignite this fire more and more daily.
For a young maker like myself, labs like these helped me start my journey into the world of technology.
Good evening, ladies and gentlemen. I am Arti Mohan, the scholar of St. Joseph's College of Engineering and Technology, PALAI, and I will be your host throughout this section. Welcome to the second day of AICTE Training and Learning Academy online faculty development program on next-gen AI, innovations in machine learning, deep learning, and generative models. This prestigious event is organized by Artificial Intelligence and Data Science Department of St. Joseph's College of Engineering and Technology, PALAI. This section, which is the section number 3 of the program, focuses on application of supervised learning and technology in machine learning using images. Today, we will explore the transformative potentials of supervised learning in machine learning, focusing on the methodologies and algorithms that drive advancements in image processing. Before we start, I would like to introduce the chair for this section, Mr. Dheeraj N., Assistant Professor in the Department of Artificial Intelligence and Data Science at St. Joseph's College of Engineering and Technology, PALAI. He is a dedicated teacher and a strong supporter of innovation and learning in the field of AI and data science. He will guide us through this section. Thank you, Mr. Dheeraj, for joining us today. Over to you, sir.
Thank you, Arati. Myself, Dheeraj N., Assistant Professor, AD Department, SJCET PALAI. Now, I'm excited to introduce our esteemed speaker, Dr. Jisha Anujos. Dr. Jisha is currently a senior software engineer at Quest Global. With a strong academic foundation, she holds a PhD from APJ Abdul Kalam Technological University, Trivandrum, specializing in digital image processing. She completed her doctorate in July 2022. With over 12 years of professional experience in academia, research, and industry, Dr. Jisha has made significant contributions to the field of artificial intelligence. Dr. Jisha's technical expertise spans across machine learning, deep learning, natural language processing, and computer vision, to name a few. She is also well versed in tools and technologies like Python, MATLAB, TensorFlow, and Azure ML. In her current role at Quest Global, Dr. Jisha has worked on innovative projects that focus on the application of AI and machine learning in real-world problems. He has applied supervised learning techniques and deep learning methodologies to various domains, including image processing, natural language processing, and predictive modeling. Dr. Jisha is an accomplished researcher with more than 7 publications in SCIE, IE, Index and Scopus Index journals and conferences, contributing significantly to the fields of machine learning and artificial intelligence. Her work has been widely appreciated and recognized in the research community. In addition to her technical expertise, she has received accolades for her innovative approaches to problem solving and her ability to bridge the gap between academic research and practical applications. Today, she will share her insight on the topic applications of supervised learning and algorithms in machine learning using images. We are indeed fortunate to have someone of her caliber to guide us through this fascinating topic. Ladies and gentlemen, please join me in welcoming Dr. Jisha Anujos. Over to you, ma'am.
Thank you, Dheeraj sir. I hope my voice is audible to you.
Yes, ma'am.
Yes, ma'am.
Okay. So, hi participants. It is very happy to see that these many number of participants have joined and they are interested in learning more about AI and machine learning. So as Dheeraj sir has mentioned, 7 years before I was also a professor working in an engineering college. Then I joined PhD, where at that time I first come into into the world of AI. I have previous experience in image processing, but I had never worked in AI. So during my PhD time, I was involved into different machine learning and deep learning model creation, training, and everything. So after that PhD has actually given me like a breakthrough to to explore other areas. Like that's why I have changed my career into an organization, into an MNC, where we'll be more dealing with more real-time applications and data sets. So in my current organization, I have worked in various computer vision computer vision projects, like mainly on classification, object detection, segmentation projects. And for the past 2 years, I have been involved in various generative AI projects. So, so currently in this session, we will be more focusing on two image-based topic. So as I've mentioned, during my PhD, I started my PhD in the year 2017. So back then, I told I didn't had any information. I didn't had any experience in AI. So I also searched many FDPs like this to get some information, some good knowledge about what actually is happening inside AI. So what is AI? But what I felt is, whenever I went to some FDPs, most of the sessions are just giving us the practical, the theoretical part, and they always mention that CNN is a black box. So I always wondered what is actually happening inside CNN, but I didn't get any information further, like deep information about what is just happening inside the CNN back then. So, but I know in the current scenario, we are. Uh, is my voice audible?
Yes, ma'am, you are audible.
Oh, okay. So, in the current situation, I know we all have a number of generative like transformers that is available for us, which give us what content that we require, like GPT models. So we are actually blessed to live in this particular time with all those transformer and GPT based models. So I wish to share, I will share my screen, and I wish to show an interesting thing that I have seen today. So that actually accidentally I saw that, but I think I should share that with you. So this was one of the paper that I come across accidentally today. So what interested me is, you just look, that is a paper on open air artificial intelligence platform in nursing education. So you just look at the authors. First one is a person, while the second author is ChatGPT. So that is the era in which we are living. So ChatGPT is a co-author of a particular journal paper. So in this current situation, it is like we have lot of information that is available in our hand. But what we fail is, we don't know what is internally happening. So all theoretical part we know, but we should also get some practical knowledge about what is being done, or how a model is being working, or how it is being trained and everything. So I strongly believe that whenever we learn some theoretical part, we should also try to implement that. You should do some hands-ons. So in this session, we'll be fully doing a hands-on. So I will be sharing a Colab notebook, because I know many of you will not be having any Python installed in your system. So, and Colab, as we know, that is supporting. They are providing us with free GPUs. So I am also switching on to Colab notebook. I will be sharing a link. So my humble request to you is that although I have written all the cells, it is running properly now. But what I need is you need to go through each and every line of the code, understand what is happening there. Just then only we will be learning it, right? So my request is, we can learn together, we can run each cells together. I will explain each cells, and in between I will explain what this particular thing is actually in theoretical, more not more detailed, but for your understanding. Okay, so I will share the link for the collab. I think everyone is open in your systems, right? So I have shared the link in the chat box. So please open it. And please give me some thumbs up or something, because it is, I can't know whether you are able to understand or, yeah. So once you have opened the collab, please let me know somehow. Okay. Hope everyone is able to open the collab notebook. Please give me a thumbs up or something, because I see only 9, 10, 12. Okay. So all is well, I think we can start, right? Okay. So I think you are familiar with Colab Notebook. There are other Python compilers like PyTorch, PyCharm, Spider, Anaconda. But the most available for everyone is Colab Notebook. So whenever you start a new notebook, this is how you will be seeing the screen. So because I have made some changes in the given notebook, that's why I am showing it from scratch. So we'll be having a place to name the collab notebook. Okay. And the next thing you can see is if you connect the collab with a particular runtime, you can see how much GPU, how much RAM is provided to you, and whether a GPU is provided to you or not. So it is connected, and you can see 12 GB RAM is provided, but there is no GPU availability here. So that means this particular notebook will be running on the CPU. Okay. So what you can do is, if you want to initialize any accelerator like any GPUs, you need to go into the edit option. There we have a notebook settings, and currently you can see the accelerator is only that is only using CPU. So other GPUs that is freely available to you are T4 GPU and V28 TPU. So you can select for our applications GPU will be sufficient. Okay, so once you select it, okay, that particular accelerator will be available for you in this particular notebook. You need to save that settings. Once you have saved this, whenever you open this particular notebook, if your if your GPU utilization is within the free instances that is provided by Google, then you will be able to get that GPU. So you don't need to repeat the same process like doing the notebook settings. Once it is set, it is always set that GPU will be utilized automatically. So coming to our Colab notebook, so you can check because I have already loaded the notebook with the T4 GPU accelerator. Okay. Hope you are able to follow me, right? If I'm moving a little bit faster, you please stop me in between because if this space is okay, then please give me some thumbs up. Okay. Okay, the settings is in this edit option. In the edit, you can go for the notebook settings. In the notebook setting, you have the hardware accelerator. And if you're not using Python and if you're using the R language, you can select that too. Once you have selected the accelerator, you can save it. Hope you got where it is. Okay. Good to go? Okay. Okay. So I will give a very brief idea, like brief introduction on what machine learning is. As we all know, machine learning is learning or making a machine learn something, or we can say transferring knowledge of a human to a machine so that the machine can do those process without any human intervention. And how we are learning this, how we are making this model to learn by using a large set of data. For example, one such machine learning like model that we come across daily is our Gmail, where the email will be categorized as spam or not spam. Okay. So that is a machine. So what they have done is they have created a model with a large data, which is trained on a large data, which can separate a given email into a spam or not spam categories. And this machine learning, basically, we can say they are of two types, supervised and unsupervised. There is one more that is reinforcement learning, that is a bit different. But basically, we say it is supervised and unsupervised. So I know everyone is familiar with this, but I will just give a small introduction. So what is supervised learning? Let us consider, I don't have any knowledge in the language French. So I am going to a French speaking country. So I need to learn it. So what I do is I have a teacher who have some friend who is teaching the French. So what I will do, every knowledge, all the teacher will be teaching me so that teacher's knowledge is transferred on to me. So from the teacher, I am learning the French language, everything, the phrases, everything. So once the entire knowledge that the teacher had in French is being captured by me, I don't need the supervisor anymore. So then I can remove the supervisor. No, then I don't want the teacher. I can go and meet some people who speak French, and I will be able to like respond to those situations. So that is supervised learning. So we have a supervisor here in supervised learning whose information or data will be transferred into the machine. So the machine is learning from the knowledge of the supervisor. Once that entire learning process is completed, the machine is good to go in a real world situation. So the machine can be placed in some real world situation, and when a new a new case come, the machine can automatically respond based on the information that they have received. So that is supervised learning, and we know the most common supervised machine learning techniques are classification, techniques. Next is unsupervised learning, where we don't have a supervisor in the scenario there. Instead, if I, without any learning French language, I go into a French speaking country where I meet many people, and from them, gradually I capture some of the patterns. So this is how they speak in this particular situation. So I am learning from experience, by looking into certain patterns. So that is unsupervised learning. So there is no labeled or supervision taking place in unsupervised learning. And the most common example we say is the clustering operation. So this is the main difference between supervised learning and unsupervised learning. And as I mentioned, supervised learning basically consists of classification and regression techniques. Classification, everyone know what is classification. If we have an input data, we will be categorizing that input data into any of the classes, like a spam or a non-spam class. That is classification process. The main thing that you need to understand is, in a classification, the output will be always categorical. It is either class 0 or class 1. While when we come into regression, that is a predictive model. That is actually predicting a continuous value. What is meant by continuous value here is that will actually generate an exact value to a particular corresponding value for a particular data. Like I have, I want to send my, sell my home as a rent space. And how is this rent calculated in this particular year? Then I met, and some is saying it is based on the build year of your house, the number of bedrooms, the square feet. So these are the parameters that is usually considered for calculating the rent. So for that, I have a model which was pre-trained, okay, on a large data set, on the previous data set. So what this model does is, based on my input, they are actually giving as a particular value, like a float value, for that is you can access. Okay, you can ask for a rent of like 25,000 for this particular features. So that 25,000 value is actually predicted by the regression model. While in classification, we don't have such specific value, specific answer like this, like a continuous value that, like this, only categorization, class 0 or class 1. Hope you are able to follow me, right? Is there any questions till now? Yeah, Mohit. Mohit, can you type in the question that you have? For the classification, what I mentioned is like a binary. If it is a 2 class, we call it binary classification, 0 and 1. If there is possible that we can have many number of classes, that is not a problem. Multi-class classification is also possible. Supervised and unsupervised learning. Supervised learning is like if we have, I will explain in terms of classification process. I have 50 images of cat, 50 images of dog. So how I can transfer this knowledge into a model? That is by, I will pass this 50 images of the dog along with its label. That is, these 50 images belongs to dog. So I will not just pass the image, but I will be passing the image along with its label that this image corresponds to dog category. Then I will be passing the other 50 images of cat along with its label that this belongs to the class cat. So that labeling information is also being used in training the model. So that is called a supervised learning model, okay, supervised learning technique. While unsupervised, there is no such labeling things present. The model or the machine will be learning by finding some patterns. like for example, clustering. If we have a clusters of we have a group of circular objects placed and star shaped objects placed there on a floor. So how can we categorize them? We'll be categorizing based on some shape, no, by looking into the patterns. Oh, these are the round shapes, so these will belong to one form. So that is actually learning by seeing the patterns. So that is unsupervised learning. There is no labeling involved in unsupervised learning, but labels are used in supervised learning. So I hope that is clear for you. The supervisor in machine learning is the data that we are using for training. Okay, so I will move forward. Otherwise, we may not be able to finish this. Okay, so one more request I have is you please make a copy, save a copy in your drive, because if you are adding something, you can add whatever, like if you get some information from my side, you can add here by typing in the text. Okay, okay. So if we get some new ideas or something, you can add into your notebook. So you please save the same Colab notebook into your drive. Hope that is done. So we can move forward. So what are the steps that we should look into for developing a classification problem? So in a classification problem, initially the thing is we should have a data, that too labeled data. So I hope you are clear with what is labeled data. That is, if we have a cat class, we should know which all images are belonging to the cat category, while those belonging to the dog category. So that data set we should require, and labeled data set. The second thing is we need to do some, okay, that I will explain later. Then we need to split this data so that some of the set of data can be used for the training process. We need to transfer the information to the machine so that the machine can learn, okay, this is a dog image and this is how a cat image looks like. So that splitting of data is required. And then finally, the classifier, that model, after training, the model is developed, then we will be evaluating the model. So these are the basic steps that is usually done in a classification. So initially you need to connect to any runtime. Oh, I don't have a GPU. If you have a GPU, you please connect with GPU. CPU is also fine. Okay, Spider code will also run in Colab. That's not an issue. Okay, hope you have connected with the runtime. Okay, then we can run the first cell where we are actually downloading the database, like a data set of dog and cat images with around 23,000 files belonging to the two classes. Okay. So once this execution is done, you please look here. Here we have a folder structure here. If you press this, you will be able to see this particular zip, Kaggle cats and dogs 5340.zip file. That is the database that is being downloaded. So since it is a zip format, we are unzipping it. So we did the unzip operation. So that particular images are given in this particular folder. So all the images for the training, like model training, is in the pet image folder. So if we click here, you can see there are two categories, two folders, one for cat and one for dog. And in each folder, we are having the set of images. Okay. Hope you were able to download the data set. This data set is actually downloaded in this particular session of Colab. This is not a permanent session. Once we got switch off from this session, this data will be lost. This is not a permanent storage or something. Unless you are saving it into a drive, it will not be saved. This is just for this particular session. Okay. Did everyone downloaded the data set? This first code is successfully run. Okay. So I got one response, so I am moving forward. Okay. So we can see this is the data set with 2 folders. And as I have mentioned here, we are having around 23,000 files in total from this data set. So since we will not be using the entire files, entire 23,000 for our current session, I'll be limiting that to around 200 images. So initially, for loading the images, we are importing some of the packages, OpenCV, NumPy packages, and I will be providing the data directory of the data set. So how we can get this? You can see the 3 dots here. You can take the copy path and paste it. So that will be your directory path. So the same content, images. So that is the directory path. You can give the directory path and the classes. So here we have classes cat and dog. So the class names are provided. Once data directory and classes have been set, the next is loading of these images into the session. So currently we have the data set in this folder. We need to load that into the script. For that, I have written a function, load images and labels, where we'll be inputting the directory and the classes. And here, this is a particular variable that I have used to limit the number of data to 200. Okay, I have given this value as 200 here to limit that images in each class to 200 for the training process. Okay, that you can remove if you are doing it yourself later. So once we have passed these 3 parameters, the script will be iterating through each of these folders, and it will look into the image files which ends with JPG, PNG, or JPEG. Only those image files will be loaded. And for loading, we'll be using OpenCV, OpenCV library, and we are importing the image in a grayscale format. Okay. The actual image is RGB image, but here we are just for simplicity, we are using it in a grayscale. We are loading it in grayscale, and then we are resizing the images into 128 by 128. Because this resizing operation is important, because some of the images may be like 150 by 150 size, some may be of 16 by 16, like that may vary. That is not a good size for classifier training. So we always resize or make all the images with same size. So here I have selected images of size 128 and 128, and this is being appended into a list. So images along with its label. Label means dog class or cat class. So here instead of dog and cat, we'll be inserting it as zeros and ones. So if you run this particular cell and the next one, it will show what is the size of the data set that you are currently using. That is 400 in total. And the class labels are 0 and 1. And number of classes in the class 0 is 200 and in class 1 is 200. till this is fine. Right? Okay, you have seen the size of data set, right? The size of images in each classes. We have limited that to 200 now. Okay, so we have loaded the data into a list along with its labels. The next thing that we are going to do is feature extraction. So what is the need for feature extraction? So why can't we give an image as such? Because currently we will be looking into the normal machine learning techniques. Like we will be trying to train the classifiers like SPM or KNN. So in that case, it is not good to pass the image as such. So I can show why it is. So if we take an image, whenever we pass this data, this feature, I mean the data into the classifier, that should be in a one-dimensional vector format. So what happened if we have an image of size 128 by 128 but traced into a one-dimensional format? That means its size will be around 16,000. So vector size will be around 16,000. That is a huge amount which can increase the complexity. That is one thing. The second thing is, if you look into the image, the most important pixels may be concentrated within a particular region. Look, this is the cat image. So this is the cat pixels. The rest, all the pixels are the background pixels. So what the image, for better learning, the model should be trained or should be focusing on these cat pixels rather than going into the background. So this background information is actually a redundant information there or noise information. But when we go into the second image, here, majority of the pixels are having the cat image, like cat pixels, but very less is having background image. So that's why it is better to extract some features, the most important features from the images rather than passing the image as such into a classifier. That's why we will be doing one of the simplest feature extraction method. I have selected a Hogue descriptor, Hogue feature extractor, which is actually
It's not audible.
sorry. Okay. So Hogue descriptor I selected as a random just for a feature extraction that is mainly used to extract textural and shape information. That is, I'm not saying that this is the best descriptor. Just for showing you, I have selected this Hogue descriptor. There are other descriptors like wavelet or other frequency transforms which work better than this. So I will just give what a Hogue descriptor is. So this is the image that it is that we are using for Hogue feature extraction, that is bolt image. So we'll be applying a filter like a swabble filter for extracting the edges. So what do you feel like? Instead of giving the original RGB image, more specific features we can see here. Now, based on the structure, we can get more edge features by if you're using this particular image as an input. So instead of giving the image again from this particular gradient features, we are extracting histogram. Histogram is nothing but we can consider it as a graph which is plotted between pixel intensities and the count of each intensity. So you don't need to be like scared of this, but I know there are many people who doesn't know image processing. So you just understand like we'll be splitting these images into smaller cells, each having a fixed size like 8 by 8 cells or something. And for each cell, we'll be generating or we'll be creating a histogram. And histogram, as I have mentioned, histogram is a graph between intensity and the count. So here, instead of intensity, we are taking the gradient magnitude, or we call it as the angles, orientations. So based on orientations, for each cell, we'll be creating a histogram. Once histogram for all the cells have been generated, we'll be combining certain number of cells together to form a block. That is block normalization to get the final normalized histogram. So you just need to concentrate on three parameters here. One is the cell, what cell means, then the orientations or the number of bins of the histogram, and the third is the block normalization. So when we apply a Hawk descriptor, we are actually passing these three parameters. That's why I thought to give a small idea on what these three are. So we'll be using the Hawk descriptor from scikit-learn package, where each image will be passed one at a time to the Hawk descriptor. And I have fixed an orientation to 9. Like 9 bins will be there for each histogram. And the number of pixels per cell is taken as 8 by 8. And we'll be like combining 2 by 2 cells together to form a block. So these are the parameters that I have given for feature extraction in Hawk. Once we are extracting the features, all these features are appended into a list and returned. So if you run this, we can see feature extraction is taking place. And we have completed the feature extraction. Now let us see let us visualize one of the histogram feature, Hawk feature. So this is how the Hawk feature looks like, one of them. For one image, this is how the feature looks like. Okay. So there is more than 8,000 features for a particular image. So when we consider, if we pass the entire 128 by 128 size image into 1D format and pass, then it was 16,000 features like vectors. But here we have reduced that to around 8,000 features. So that will reduce the complexity, as well as the model will be able to able to learn more on the important features. Okay. I hope you have come across till this particular set. So this is the visualization of one image feature. This is only for one. Next is one thing that is not a compulsory step when you do any machine learning techniques. The second one, but I think it is better to have some insight into the data set, like into the feature set that you are giving to train the model. For that, we can do a visual comparison. Since this data is having around 8,000 dimension, we are not able to view an 8,000 dimension vector. So to visualize, we'll be reducing this feature into two-dimensional vector using PCA or TSNE. Okay, the most common one is PCA, so I have also selected PCA. So I reduced this 8,000 feature into two components, and I have plotted it. So this is how we'll be getting our features, where blue dots denotes class 0 and orange dot denotes class 1. So from this, we can see when we see a cat image and dog image, we can easily distinguish that but the features that we extracted are actually not providing such easy separation between the dog class and the cat class, because we can see some of the dogs and the cat feature points are overlapping with each other. So this is a two-dimensional view. So let us see whether in three-dimensional view whether these features are separable. So this is how we will be getting the three-dimensional representation. Still, it is not that easy to separate. Okay, I will show another plot what I meant by easy separation. Okay, so this is one sample case. This is not our case. Sample case where we have class 0 and class 1 and class 2 with very good separation. So if we get a data set like this, no, like feature set like this, we can easily say, oh, this is very easy to separate. We can just use any linear classifiers to separate these two, because a single line can easily separate this class from this class. Okay. So that is possible. And in three-dimensional, sometimes in two-dimension, we feel like, oh, this is not easily, like there is overlapping between the classes. We are not able to separate in two-dimensional, but in three-dimensional, when we can see these two are actually separable by using a plane. So such an information. So without applying all the different types of classifiers in your application, it is better to have an insight into the type of data set, like the feature set, by plotting like this, and you can come across. Now if such easily separable feature set is the one that you have, then you can go with linear classifiers like SVM with a linear kernel, or logistic regression, or perceptron. But if that is overlapping, heavily overlapping between the two classes, then we should go for non-linear classifiers like SVM with non-linear kernels, decision tree, KNN, or random forest. So such an understanding we can get by such a visualization. I hope this point is clear to you. So this is not a compulsory step that you should follow, but it will help you in getting more understanding about the data that you are handling with. Everything is clear, right? You have run till the visualization cell. Okay, so once now I understood that, okay, our data is it is almost like non-linear. We can conclude that because I have reduced that 8,000 features into 2. So that is a drawback, but still we are getting some insight, like it is overlapping. So might be a non-linear classifier may be working fine for us. So next step that we need to do is splitting our data set into training, validation, and test set. So usually everyone know what a training set means. That is the set of images that we are use along with the labels to train the model, or to make the model understand, okay, this is the type of images that corresponds to this class, a cat class, and this is the type of images that corresponds to dog class. So that is training set. But most of us are not that, maybe get confused with validation and test set. So what validation set actually means is, I have trained a model by a set of images and labels, and that training is completed. Then I need to check, okay, whether this model, I actually consider an example like I have trained the KNN model and an SVM model, and both are actually giving 97% accuracy in the training. So I'm confused, like which one should I use? Or I have used SVM with linear kernel and or RBF kernel and another kernel, and I'm confused which one to select. So some hyperparameter selection as well as some model selection is confusing me. Then how can I come to a conclusion this particular model is, or this particular approach is better? For that, we'll be using validation dataset. That dataset is actually used to evaluate the model selection criteria, or how the model hyperparameters have to be changed. Whether this particular hyperparameters is working fine, or should I change the hyperparameter? So that decision we will be making based on the result of the model on validation set. That is not the test set, that is a set of images that we are using to evaluate the model or evaluate whether the hyperparameters of the model are the correct one or not. So that is validation set. While test set is like we have trained the model for categorizing some images, like we can say medical image, and we are implementing that model to a doctor site. So there, new patients will be coming, new data is coming, then the model is predicting on those new images. So that set of images, we call it as test set. Okay, so these are the three.
Humbly request all the participants to mute your mic.
So these are the three sets of data that we come across in machine learning techniques. So next step that we are doing is we are splitting our features. Here, now our images have been converted into features. So now our features are our data along with the labels. Labels are the class name 0 or 1. So we are using again scikit-learn function train test split to split the features along with the labels into training set, test set. Actually, this is validation set and their corresponding labels, y train and y test. So what does test size denote as? I have given it as 0.2, that denotes 20% of the entire set will be used for the testing process, while like the validation process, and 80% we will be using for the training operation. And stratify is to make sure that then the distribution of classes in train set and test set are same. That is, if we have 20 images of cat in train set, like a test set, then the test set should also have 20 images of the dog class. So to make that balanced in the images in the classes, we have used this stratify. And one more is the random state. That is, once I did this, I evaluate the model. So tomorrow, if someone asks me to reproduce the same result, then we should split the data in the same xtrain, ytrain format, no xtrain, xtet format. For that, we'll be using random state with a fixed integer value. So if this value is fixed, then always the same split of data set will be taking place. So we have splitted our feature sets into train and validation set. You can see the size, that is 320 more images will be in the training set and 20% of the images are given into the test set. So hope you are with me till the train test creation. Yeah, then we can move forward with classifier. So initially, we'll be looking into some linear classifiers. So we'll be using logistic regression. I will not be going into the deep, like theoretical part of logistic regression. But one thing you understand is what happens during training in logistic regression is they try to find the best fit line. That is like a line to separate between the two classes. Line or a plane, we can say. So there should be some line that will easily separate these two classes. That line is being determined while training a logistic regression line, or we can say a plane. So whenever, so here we are initializing the logistic regression model and we are fitting the model. The fitting is the training operation using train set, the training feature set, and the corresponding labels. So when this is done, initially some random line, like line equation, the line equation we'll be having with some intercepts and slope, everything initially. Then what happens during training? For each training operation after training, these intercepts and the slope will be adjusted such that the error is minimized, because we know the label for this particular image of this particular input, this should be the output label. So based on the error that is happening, this slope as well as the intercept values will be adjusted till we will be getting the best fit, the correct or the final better classifying logistic regression model. So by this fit operation, we train the model and then we are using the model for predicting on the validation data set. X test here denotes the validation data set. So we have trained, I hope you run this code, you have trained the logistic regression model and you have done the validation. So once validation done, the next step that we have is we need to check how the model has performed. For that, we have a classification report. The basics of classification report will be based on confusion metrics. So this is confusion metrics. I know you are familiar with confusion metrics. So this is the actual class. This is the predicted class. So if true positive means all the positive cases actually positive are being predicted as positive, we take it as the true positive case. The positives that are predicted as negative, we take it as false negative. Okay. Similarly for the negative class. So this is a confusion matrix. So whenever we do a classification, this confusion matrix will be generated, and based on that we will be finding various performance matrices. The most commonly used matrices are precision, recall, and F-score. So what precision is? Precision is true positive by true positive plus false positive. So that means among the predicted positives. So you need to understand that is precision. We will be talking in terms of predicted case. Among the predicted positive case, how many are actually positive? That is precision. Among the total positive cases being predicted, how many are actually positive? That is precision. The second is recall, true positive by true positive plus false negative. That is based on the actual label case. True positive by true positive plus false negative. That is among the actual, how many of the actual positive cases are being predicted as positive? That is the recall value. Recall is based on actual label. That is among the actual positive cases, how many of them are actually correctly predicted as positive? That is recall. While precision, we will be saying in terms of predicted labels. Among the positive, among the predicted cases in the positive class, how many are actually positive? That is precision. Then F-score is a mean of precision and recall. If we have a good model, we'll usually have a high precision and recall value, and hence we have a high F-score value. Then the accuracy, that we know what is accuracy means. The total correct classification gives us the accuracy value. So there are some cases in which we may look into recall more important than when compared to precision, and some cases where precision can be given more importance than recall. For example, let us consider we are classifying a medical image with cancer or not cancer. So positive class is the cancerous class, negative is not cancerous. Which is more dangerous, you think? If a person having cancer is not being detected as cancerous, that is more dangerous. If the other case happens, if a person is not having cancer, but he was detected as having cancer, he has another option, right? He can do a second test to verify. But the first case, no, if a person is knowing, oh, I don't have cancer, but actually he had cancer, that is more dangerous. In such cases, what is positive class is cancer, the actual cancer person. So actual cancer person is not being detected as cancerous. So in that case, we can say false negative should be low. Then only our model is a good performing model. What if a person with cancer is not being detected as positive? That means recall should be high in such cases. While we come into the precision, some cases where precision is more important, we can say the spam classification itself. Sometimes we may be getting some spam emails also into our inboxes. That is fine, we can delete it. But what happens if our most important email goes into spam? We never know that it went into spam. In that case, the predicted positives should be belonging to positive only. That is, this is the spam class. So the whatever that is being classified into spam should be spam, not the non-spam should go into spam. So in that case, precision can be given more importance. So this type of analysis you can do when you are doing some projects, like based on your application, you can decide whether a recall should be given importance or precision should be given importance. Then the next thing that we usually find is macro average matrices and weighted average matrices. Macro average will be giving equal weights to each classes. That is, this is usually preferred if we have a balanced class. We'll be taking the average of precision of each class to find the average precision value. While weighted average will be using the number of images in each class also as a weight in calculating the average precision. So this is usually helpful if you're using an imbalanced data set. Hope you are clear with this. So then we can see the confusion metrics and the classification report of our logistic regression that we have trained. So this is the precision value recall for each class, macro average precision, macro average recall, F-score, weighted average value, and the final accuracy value. We are getting about 63.75% accuracy. Is this fine? Everything is fine. Did you get this classification accuracy till now? So we are also trying to train another linear classifier, SVM classifier with linear kernel. Here also we are actually trying to find a hyperplane to separate between the different classes or different features. And this is actually the hyperparameter that I have mentioned, the C value. We can change it based on the performance of the model. But after evaluating the model, we may change the hyperparameter of the model. Okay, so this is just a repetition. Just I want to show that there are other classifiers also, how that is working. So here we get 66.25%. So there is an improvement. Okay, so there is an improvement by using SVM with linear kernel. Now we can also try some non-linear classifiers. Here the same SVM with a kernel, RBF kernel, and there are other kernels also like polynomial kernel where you can adjust the degree of polynomial, 2 or 3. So these are called as the hyperparameters of the model. So you can adjust it. One suggestion is you don't try like 2, then 3. You need to adjust each hyperparameter individually. Once you try with 2, you check the evaluation or the performance of the model. Then you can try with 3. Then you may go into RBF, RBF kernel, some other kernels like that. So here we are also using another non-linear kernel RBF. You can check whether, okay, here again 66%, 66.25% accuracy. And another is K nearest neighbor classifier. Okay. So a KNN classifier is also called as a lazy classifier because actually it doesn't does anything during the training process. That's why it is called a lazy. It just sits like that. And whenever a test image comes, it will get active. That is what KNN classifier does is we'll be having this feature set. This is our feature set. So my input data is somewhere here. Okay, let us see here. So KNN classifier does is it will check the distance to k neighbors. So that k value we can decide. So if I am taking like k equal to 4, I will be checking the distance of each and every points to this particular data point and check which are the most common, the most closest 4 neighbors. The 4 neighbors, let us say this one, this one, this one, and this one, these 4. So among these 4, which category is more? Blue category. So what we do is the model will will determine, or it will conclude that this particular data set belongs to the blue class. So this is how a KNN classifier works. So in the training process, actually, there is no training. It's a lazy classifier. It sits like this. Whenever a new data comes, it will start working. It will find all the distances and find the most closest one. And among them, that will decide what should be the label. I hope this is clear. So that's why here in KNN, we have one hyperparameter, that is number of neighbors to decide. Here we have given n equal to 4. The performances have gone down 57% accuracy. So this is one easy classifier, I can say. The next is decision tree classifier. It is having a tree-like structure, more suitable if we have more non-linearity. Okay. So decision tree is actually based on a set of if-else condition, something like that, if-else condition. We will be having a root node, which will be splitting into different nodes. And finally, we have the label nodes or the leaf nodes. So the splitting will be decided based on some categories, some parameters. So whether we should go in the right direction or the left direction. So that decision we make. No? So the similar thing also is happening in decision tree. So decision tree is fine. You are with me, right? This is just to make you understand there are these many classifiers, and you can easily import all these from sklearn. So there is nothing to be worried. Everything is there and everything is documented in sklearn documentation. You can simply go and run it. You'll be getting the result. So the next one, the most common one, is random forest classifier. So random forest classifier, as the name suggests, it is a forest of trees. We are having a number of decision trees. Many decision trees together forms a random forest. So here the hyperparameter that we have is number of estimators, that is number of decision trees that is to be used. Here we are using 100 decision tree classifiers. What it does is, one of the decision tree will be trained, the second will be trained, and all the hundreds will be trained on different subsets of the training data set, and majority voting will be taken to find the actual final label of the input. So that is random forest, so very basic information. So by decision tree, random forest, we are getting 53.75% accuracy. Hope you have completed till this. Yeah, the one thing is that our feature set is not that correct. There is a question that why we have a less accuracy. So one thing, that feature set I selected is one random feature set, Hogue feature. So that is one method. If you're doing a research or something, we can like look into different descriptors. There are many other good descriptors other than this Hogue that is more suitable for our use case. So we can try Hogue. You see this, its accuracy is only around 70. Then you can go with other feature descriptors and do the process, or you can change to other classifiers. There are other ensemble classifiers also, or you can even train an ANN classifier, which will be training or learning more on the data. So that's why this is actually a random selection of feature descriptor. Okay. So everyone have run till random forest classifier, and is that okay, right? This algorithm, which algorithm is better? That is the only way we can evaluate an algorithm is based on this performance matrices. That's why we will be looking into this matrices. One like trial and error method, that is the one we will be usually doing. And this is some basic classifiers. Currently, there are many other classifiers also. There are ELM classifier is there. So there are many more new classifiers. So we may need to, if you need to improve your accuracies, you can look into those recently developed classifiers also. One thing that you can do is you can try different feature descriptors. Then the second thing is you can try changing the parameters, like hyperparameters of some of the all of the classifiers. And then sometimes also we can do one more thing is that if we found we found like linear classifier was working fine for our case. So we have an SVM classifier with 66% accuracy and logistic regression with 63%. So one thing that you can do, you can ensemble these responses from these two classifiers to generate a new response. And that ensembling process usually improve the accuracy. So that is one method. Okay. So till now, I think you are with me. Now, as I have mentioned in KNN classifier, we have this particular hyperparameter number of neighbors. That one method we can do is we can give 1, then we can give 2, then give 3. So instead of that, what we follow, the best practice is to follow an elbow method. Elbow method is nothing but we'll be giving a range of k values, and for each k value, we'll be training the KNN model. We predict the accuracy, and based on that, we'll be deciding which is the best k value for the classifier. So let us run for our case. Oh, you will be also getting this error. You please change that xtrain scale to xtrain and xtest scale to xtest. Okay. Are you getting any errors? If you're getting error, you please change that xtrain scaled to xtrain, xtest scale to xtest. Okay. Yeah. So we have actually plotted the accuracy for all the 21 k values. So how much is this? So this shows that the best accuracy is for k value equal to 3, and that is 58.75%. So this is how this method is called as elbow method. So instead of randomly trying, okay, if someone asks, why did you select k equal to 2? So you should have some answer for that, so that that answer should come from elbow method. You have tried elbow method and you have decided based on the result, which is the optimal k value. So till now, we have splitted our data set into a fixed set, training set, and a validation set. Then we have evaluated the different classifiers. So for getting a better model on the given data set, we can do cross-validation. There are different cross-validation techniques like k-fold, stratified k-fold, and leave one out cross-validation techniques, and I will be discussing k-fold. K-fold is nothing but we will be splitting our data set into different sections, or we can say different sets of training validation data sets. If I set k as 5, that means I'll be dividing my data set into a particular training set and a validation set. Again, the second k value, I'll be again dividing the same data set, the entire data set, into a different training set and a validation set. So I repeat this splitting process 5 times, and I will be using each of these data sets to train my model. And the performance matrices of all the 5 trained cases will be averaged to find the final model accuracy or model performance. I hope you got it. You will be splitting our data set into training and validation sets 5 times. And each of these set will be used to train a model. And for one fold, the model will be evaluated. We'll be finding the accuracy. The second fold, we'll be training the model. We'll be getting the accuracy. And the average of these accuracies will be taken as the final accuracy. So that is k-fold cross-validation. So here I have selected random forest classifier with 100 estimators and have set the fold as 5. So 5 times my data set will be splitted and 5 times the random forest classifiers will be trained. So this is how we'll be getting. For the first fold, I'm getting an accuracy of 68.75. So why we are doing this? If let us consider, I have splitted my data set into this, into the first set of training and validation. But that is not the exact generalized data, no, a generalized model, because in that particular set, my model is actually giving 68% accuracy. But what about the other set? It's 58, 66, 61, 63. So if we conclude by this that my model is having 68% accuracy, that is not a well generalized model. So better thing is you can do a cross validation on the data set, so that we'll be taking the average of each folds to decide whether our model is performing a generalized model or not. So by taking the average, we will be getting the accuracy as 63.5%. So, explain. Did you change the variable name? Explain. I think it was capital. So I hope till cross validation you are able to understand. Okay. So what are the steps that we have seen till now is we have selected a data set. We identified what is the problem statement. Our problem statement was to separate a cat image and a dog image. So first thing is we need to have a clear idea of what our problem statement is. And we should have a good data set also. And always try to have balanced data set. Or if we don't have a balanced data set in a particular class, we have less number of data, we can provide some image augmentation techniques. I am not taking that portion in here. We can apply different image augmentation techniques so that we can make the classes balanced. Okay. So once we have the data set, the next is, since we are dealing with the machine learning techniques, we'll be doing some feature extraction methods, and you can decide which feature descriptor you should use. You can try out different descriptors and you can come up with which descriptor is best for your use case. After feature extraction, the next thing is we need to split our data set into training, validation, and the test set. And once the training set is developed, we can train the models. And in between, if you get a more understanding about the data, you can visualize it and understand, okay, this is how, or this type of classifier may be working fine for us. Okay, then we can train each of these models, change the hyperparameters, change the different models, evaluate each models on the validation data set, and decide which model to be selected. And in addition, for a better generalized model, do cross-validation. So till now we have done, okay, I have decided that this particular model is the best model, most generalized model. The next thing I need to do is I need to implement this in the customer side, right? So someone will be using this classifier, not me. I have been developed that for someone else. So I need to give this model to that user. For that, I need to save the model. So the next thing we'll be doing is we'll be saving the model in a pickle format. There are other formats also, but let us move with pickle. So when you run this pickle cell, you can see your model is being saved here. You can download it to your local system. Okay, so this will be downloaded. Once downloaded, you can pass this model to the user, and user can do the prediction on the test images. So for predicting on the test images, what are the steps that he should follow? He should read the image, convert that into grayscale, because our model is being trained on grayscale features. So here also the same process he need to do. Load the image, convert that into grayscale, resize that to 128 by 128 size, then pass that into HOG with the same parameters. orientation, pixel size, cell size. We'll be getting the features. So these features we'll be passing into the model. So we are loading our model here. You can see here we have loaded our pickle.load model file. What is the model file? This model, trained model.pickle is the model file. So if you have this pickle model, trained model, I request you to download some cat and dog images from website just to check. Okay, we can take some test images. So I have actually have a dog and cat image in my local system. So you can also download any cat or dog image from the website, and we can test it here itself. Okay. So once you have downloaded, you need to upload that into your collab session, right? So that's, you can just drag and drop it. Drag and drop, then you will be getting a warning that this file will be deleted once your runtime is terminated. So that is fine. So I have uploaded one dog image. Okay. Then I will be passing the path of this dog image. So to get the path, I click here, I get the path, copy path option. And in the image path variable, I will be passing my image path, content dog.jpg. So this is the dog image that I have uploaded. Okay. So we'll be using our trained model, that is the trained random forest model, for classifying this particular test image, dog image. So features are extracted. One thing you need to look here is we are doing a reshaping operation. Reshaping is required because we have trained the model like this. Each image feature is having around 8,000 size. And how many images were there? 320. 320 images. So this was the size of input that we have provided. So always the model will look for a data of this size, like 1,8,000 or 10,8,000, like that. So this 320 denotes the number, image count, and this is the feature size. So that is why we are doing the reshaping operation. So we have reshaped our image feature into this particular shape and passed on to the model. So this is my, okay. Fit, I don't know. Let me do that. This we need to fit the model before using it. That's what here we are not actually doing the fit operation. We are just doing the cross validation, score evaluation. So that's why. So you need to run the previous cell. Okay, that is this random forest model, and then you need to save it. Okay. this is actually to evaluate with this whether this random forest with 100 estimators is better or not. This is not fitted it. The model. Oh, RF. Sorry, RF. RF. Okay. So my model have predicted it as a cat. So you understood what the change is now. Here, cross-validation, we are actually not fitting the model. We are just evaluating the score of this particular random forest with these hyperparameters for 5 folds. We need to fit it for using it for prediction. So what you need to do is you need to use this RF model. Instead of here saving the model, here you change it to RF and save it into pickle and load it. You can download that by clicking on the 3 dots. You can download the models in any files by clicking on the 3 dots, and you have the download option here. Okay, I hope you are also able to get the prediction. If you're getting prediction, can you share some of the screenshots, because our time has been 7:33. You're able to predict it. Please share that screenshots. So I will conclude my session like we have other resources, like you can go into Medium, where they published many new recent techniques, and very good one is the documentation of scikit-learn, where every details and every hyperparameter, what it means, everything is being mentioned. And also for learning by seeing, by experimenting, a very good YouTube channel is by Krish Naik, and also machine learning course by Andrew NG is also best. So okay, so I think you are able to predict it.
Ma'am, I have a question. Can I ask?
Yeah, sure.
Ma'am, if, for a software application, like a huge amount of data is we are getting on the daily basis, like on shop, right? Grocery shop. So if I want to integrate ML in that particular software, so which database you think that is the best suitable in ML point of view, in considering the huge amount of data on the daily basis?
What is the type of data that you are trying to solve? Like, what is the use case that you are trying to solve there?
The data will be like grocery kind of. You can take an example like DMart, right?
Okay.
So there is a huge amount of data on the daily basis. So if I want to analyze the data, which database is suitable in ML point of view?
Are you getting this data in the form of like an image data or like numerical data that you are getting?
Actual numerical data, ma'am.
Numerical data. So you are having this numerical data from the past. No, on the daily basis, you are getting a number of data.
Yes. Customers billing data, ma'am.
Customer data.
I want to analyze. Yeah.
Okay.
Not
So I want to understand what is the use case that you are trying to implement. Then only I can comment on what are you trying to implement using that data.
We need to find out the customer behavior and which products are getting sold on the large basis, like this kind of analysis. What are the customer interest and all kind of things.
Oh, okay. Okay. So,
Means with the Python, which database should I choose so that I can handle the huge amount of data with ML?
database, I am not like familiar with this type of, but I think customer segmentation techniques are there. Like for your application, customer segmentation is the best model. Best
No,
thing
I'm
that
not a model, madam. I'm asking like I'm not asking the which model I choose. I'm asking like which database should I choose in order to, I mean, analyze this data? I mean, it should be feasible with ML. Right? Which database should I choose if I want to make such kind of a software?
you're asking like database. I'm not sure. Like there are a number of databases like data sets that is available. But for your application, I think you yourself is having a number of data. So what you're asking what are the fields that you should consider in modeling the model? Is that so?
No, no, I'm just asking database.
Data sets, I don't have much information about that for this.
Okay.
But I think the thing that you may be needing is customer segmentation.
Yes, that's fine.
If you have any questions, you can ask.
Hello, good evening, ma'am.
Yeah, good evening.
Ma'am, nowadays we are using deep learning to do some classification or any other recognition using pre-trained models, right,
Yeah,
ma'am?
yes.
But where we can use machine learning, particularly very useful, ma'am, because we have developed into many pre-trained model, but where we need, ma'am. So,
Machine learning mainly come into practice, mainly come into focus if our data set is very small. If we have a very small data set, then better going with the CNN or like deep learning models, it is better to use this machine learning. And also we can combine these pre-trained models with these traditional machine learning models to improve the accuracy.
okay.
That since our session is mainly on supervised learning with machine learning, I have limited with this
Yes,
machine learning.
I know, but just I
yeah.
want to know some maybe have some benefits, but I want to ask.
Yeah. So the one thing is that if our data set is very small, then it is preferred to use these machine learning techniques rather than going into deep learning techniques. And also in deep learning, one thing that most common practice found is we'll be using the pre-trained models for the feature extraction, and we can use those features for training these type of machine learning models. So that is also giving better accuracies, better results.
Okay, okay. When we are using small data, then we can use machine learning, right, ma'am?
Yeah, yes.
Yes. Thank you, ma'am. Thank you.
Thank
you. Before we conclude, we now open the floor for the question and answer section. If anyone has any doubt or questions, please feel free to unmute yourself or type them in the chat box. Dr. Jisha will be happy to address your queries.
Small means the number of images that we have. That is a row.
Yes, ma'am.
The rows that is small.
Yes, ma'am. Yes. But still, we are using in real time, ma'am.
Real time, sorry. Image size is image size may not be that much useful, I think, for machine learning applications. But when it comes to CNN-like applications, that size may have an involvement in the accuracy, because the most practice that we use in machine learning is to extract features. Extracting features may not have much effect on the image size.
Okay, thank you. Thank you.
Thank you, Dr. Jisha, for an insightful and hands-on section on machine learning. Your clear explanation of supervised learning and unsupervised learning, data loading, feature extraction, and visualization techniques made complex concepts approachable. The practical steps on creating train test sets, training models, the ELPO method, cross validation, and testing their performance, along with the use of kernels in SVM for handling nonlinear data, were highly enlightening. The demonstration of linear classifiers and nonlinear classifiers provided a comprehensive understanding of the workflow. Your connection between theory and real world applications, especially in image processing, and your insights into challenges and threats in the field were truly inspiring. This section has laid a strong foundation for exploring the transformative potential of machine learning. Once again, thank you, Dr. Jisha, for sharing your expertise and experience with us. It has truly been a privilege to have you as a speaker for this section. Before we move ahead, I would like to extend my heartfelt gratitude to the speaker and participants for this contribution, making this section a resounding success. Your active engagement and insightful questions have added great value to the discussion. Thank you once again to everyone for being part of this enriching experience. As we look forward to the upcoming section, I am pleased to welcome the host for the next section, Ms. Abha Jaykrishnan. Thank you, and over to you, Abha.
Thank you, Aradi. Good evening, everyone. I'm Abha Jaykrishnan, the scholar of St. Joseph's College of Engineering and Technology, PALAI. I will be your host throughout this session. Before we start, let me introduce the faculty chair of this program, Ms. Rashmi Annama George, Assistant Professor in the Department of Artificial Intelligence and Data Science at St. Joseph's College of Engineering and Technology, PALAI. She is a dedicated teacher and a strong supporter of innovation and learning in the field of AI and data science. Thank you. Over to you, Ms. Rashmi.
Thank you, Abha. It's my great pleasure to introduce today's esteemed speaker, Dr. Sujitra M.S. Dr. Sujitra is a highly accomplished researcher in the field of computer science and artificial intelligence. She holds a PhD in computer science from Amrita Vishwavidyapeetham and has an impressive academic background, including an ME in computer science and engineering from Anna University and BTech in computer science and engineering from Mahatma Gandhi University. She has over 10 years of teaching experience and is currently an assistant professor at IIIT Kottayam. She has also gained industry experience as a Java developer in Android at Anya Technologies. Her research expertise lies in areas like data mining, machine learning, deep learning, soft computing, and AI applications in agriculture. She has a strong track of achievements, including receiving the highest committed student branch activist award at the CSI annual convention in 2020, publishing articles linked to United Nations Sustainable Development Goals, conducting FDPs on deep learning models and use cases using Python, sponsored by the Ministry of Electronics and Information Technology. She has published numerous papers in leading journals. She also has presented her research at prestigious conferences, including IEEE international conferences, UGC-sponsored seminars, international seminars sponsored by AICTE and ICMR. She has undertaken impactful projects including rubber tapping robot, crop recommendation system, fertilizer application optimization, and recoverable concealed data aggregation. In addition to her academic and research contributions, Dr. Sujitra has organized several events, including webinars and workshops on machine learning, deep learning, and artificial intelligence. She is also a reviewer for international journals and has guided internships on topics like water potability prediction and crop recommendation systems. Her technical skills include expertise in programming languages such as Python, Java, and Android, along with experience in tools like MATLAB, Beka, and RStudio. She is also proficient in databases like MySQL and MS SQL. Dr. Sujitra, with her vast knowledge and experience, is a true inspiration to the AI community. We are honored to have her here with us today to share her insights on next gen AI innovations. The virtual stage is now yours, Dr. Sujitra. Over to you, ma'am.
Thank you, Rashmi. Am I audible?
Yes, ma'am.
Thank you, Rashmi. Thank you for this beautiful introduction. Yeah, it was something like recollecting my past, right? Anyway, thank you all. Thank you for this invitation from St. Joseph College of Engineering, and a very good evening to one and all. Yeah, it's so happy to see this much participants for an online FDP. It's something like 329, 330, right? That's quite good. And can I share my screen, Ishmi? It's not possible to share from my side.
Yes, ma'am.
It's not now. It's not. Yeah, share screen is not possible from my end.
Ma'am, try now.
No, it's not possible from my side. Whether I need to rejoin again?
No issue. I think you can try now.
Wait. No, sir. That showing like only meeting organizers and presenters can share.
Wait.
If you are giving that access, I can share.
Try now, ma'am.
It's not possible to share. It's not possible, sir.
Yeah, change the settings. Try now.
Screen not visible, ma'am.
Sir, is now my camera is on, right?
Yeah, the camera is on.
Yeah, fine. Yeah, but share screen now also it is something like only meeting organizers and presenters can share. It's not possible to share from my end. Can I share my that PPT to you?
No issue. I am trying to change the settings. Try now. I'll change.
Yeah, it's come. Yeah. Now it's come. Hope my screen is visible now, right?
Yeah, it's visible, ma'am.
Is the PDF is visible?
Yeah, it's visible.
Yeah. Yeah, you can start the session. Thank you once again for from my end to St. Joseph College of Engineering for this opportunity. I hope these are heterogeneous participants that like faculties are from different department, like from computer science, EC, or if it is from that commerce field or management field. Is it possible, sir? Faculties are from heterogeneous background, right? Yeah, hope it's so. Yeah, anyway, these many faculties are there. I'm Dr. Sujitra MS. I'm working as assistant professor in CSE department at IIT Kottayam. Here I'm going to discuss about the concept regarding the deep learning architectures and model. I had two sessions, one is today and tomorrow I had to discuss about the applications of deep learning architectures and models. So what I planned for today, I have to discuss this concept, like what are the concept behind deep learning architectures and different models in the deep learning area that I can discuss today. And tomorrow we will discuss the application with practical experience. Okay, that's my plan for the entire program. Then we have to discuss deep learning, that if it is without the knowledge of neural network, it is not good. I hope the faculties have the knowledge regarding neural network is there. Okay, once if you are going with any deep learning architecture or deep learning models, you should have thorough knowledge regarding neural network. Okay, the previous session, I was there in the previous session. I can understand you have the concept of machine learning and algorithms in machine learning. One of the algorithm in machine learning is neural network. Yeah, in between I'm asking, am I audible to you?
Yes, ma'am.
Yes, fine. Yeah. So, so that neural network concept is good. You can easily go through the deep learning architectures and model. So before starting deep learning, I can tell you like you should be check all the knowledge regarding neural network. Then only you can move with deep architectures. Why we are moving nowadays with deep architecture? It is very successful in many applications. So these three are required if you are going to start with deep learning, if you want to go with deep learning. Okay, so here I can introduce you the first learning algorithm. In neural network, so many algorithms are there, but I want to tell you this was the first learning algorithm in neural network. I'm not going to introduce this concept. I can understand those who are in machine learning field, the very first algorithm you are studying in neural network is perceptron. That means in the perceptron onwards, the learning process starts. Learning process starts in the sense, if we found out any error in your prediction, you need to change the weights of the neural network, update the weights, and find the output again. That learning starts from this perceptron concept. So the terms like input, output, and neurons, networking structure, then output, if any error is there that we need to check it out. All these things are happened or started from the perceptron concept. Okay, so the next thing I want to tell you is that if you are moving with any neural network, so many parameters are affecting, like weights, bias, okay, activation functions, okay, hidden layer, hidden neurons, the number of layers in the neurons, all these things are affecting the neural network performance. So if you are going with any neural network, you should study what are the different activation functions that are applicable in neural network. Some of the activation function I have mentioned here, that all related with pure mathematical concept. If I am telling about a function like sigmoid, then there is an equation, 1 by 1 e raised to minus x. Okay, if I am telling about ramp function, there is one equation. So you have that knowledge, mathematical knowledge about neuron. Okay, I know all of you are familiar that this is an artificial neural network. It is mimicking the brain concept and neurons in our brain system, the same way architecture we are creating in artificial neural network. So for that, what are the important parameters that you need to be followed? So just an introduction, I'm starting and I'm telling like these are the main parameters required for a neural network. How it is happening, I hope you can understand. X1, X2, etc., Xn are the inputs. W1, W2, W3, etc., Wn are the weights for that input. Sigma summation we are doing in neural network central unit. After summation, we will get net input, net output that we are applying with some activation function. Then you are getting the final output. If that output contains error or it is that actual value and the observed value is have any difference, that we can calculate as error and we will modify our model. So that is a procedure for any neural network. Hope these terms you can understand. Once you familiar with neural network, only you can move with the concept like deep neural network. Okay, here one picture is there. There you can see one input layer, output layer, and hidden layer. There is no that something like only one hidden layer only, right? We can add more hidden layers. That means we are providing deepness in our architecture. Okay, this is simply a multi-layer feed-forward network. Input layer, a hidden layer, and output layer. It's a neural network architecture. We can handle non-linear. Previous session also, ma'am explained about non-linearity, right? So non-linear things we can handle with this type of multi-layer feed-forward network with input layer and output layer and some hidden layer concept. So that concept was there in history, but 2006 onwards, we are moving with this deep learning. 2006. You can imagine that now also we are thinking about talking about deep learning, right? So that 2006 that concept came, and that importance of neural, that adding deep layers in neural network also there, but this much data availability is not there. Nowadays image, that video, audio, any format of data is available. Network connectivity that much is there. So then only we can use this type of concept. It was introduced in 2006, but that much popularity is not there. Once this concept is in full mode, and the data availability is there. So I hope you can understand the scenario. Neural network was there in history, that based on that only we are implemented. In neural network also the concept back propagation, one of the very famous algorithm in neural network, back propagation. It will providing good result. It will have a good mathematical background. That's why it is more popular. The results are also most popular. So that area also you had to go through when we are going with neural network design. But the issues in simple neural network design was the like representation. I told you it cannot handle all type of data. Simple neural network cannot represent any type of data. Neural topology, the layers, if we are adding more layers, the system capacity, okay, the network parameters, all these things are become complex. So that type of capacity is required for your system. The training and validation process become complex when the data set is high. So these issues are the, then we need to select this neural network based on, definitely to avoid, we need to avoid underfitting, we need to avoid overfitting, we need to find the best result, right? So that is possible with the help of advanced neural network. That's why we moving with a deep learning concept. You can see here with an example, I can tell you, can you guess what is the name for this type of algorithm without deep layers? Same, the name is like shallow network. Shallow neural network, right? Here you can see one example of shallow neural network. Before deep learning, all the neural network concepts are shallow. Here you can see the one graphical representation. If I am using a fully connected network with 3 layers, the result is represented in green color. 3 layers only, fully connected. There is no deep learning concept. Same thing I applied with convolutional concept. It's something deep learning concept. 3 layers. That also giving the result like this. That same deep learning convolutional concept I'm applying with 11 layers. You can see the difference. Okay, the analysis is, every analysis is providing the result. When we are adding more layers, it will giving more good result. So that is the thought process happened in the early era to go with deep learning. Okay, so that type of scenarios had happened. So easily this will be the main motive. We are whatever things in our mind that we are mimicking with fast speed, that is happening with deep learning. Okay, so that means why we are using deep learning, practical success in computer vision. That means we are handling images, signal processing, text mining. Then it can handle increased amount of data. We can handle the volume and complexity of data. Then now you know GPU systems, graphical processing units supporting this deep learning scenario. That is available now, readily available for any application. That Google Colab itself we can do something, right? So these are the motivation behind the using deep learning. Again, I'm telling it was there from 2006 onwards, from 2006. So, but we are using nowadays because of this reason, data availability and technical support. That was there. That is the main motive. Yeah, when we are discussing about neural network era, you can see from simple network architecture, it is going in different level. Okay, architecture wise, so many differences are there. Each neuron representations are different. So you can understand why we are moving with the deep concept. So many algorithms, so many structures in deep learning, all are helping to provide good result with application, different application. You can use with any area, interdisciplinary area, wherever we want to use this deep learning, it is possible with different type of architecture. If I am telling about weather forecasting, definitely time series models are there. For time series analysis, so many deep learning models are there. That is the reason we are using this type of deep learning architecture. So I told you computer vision, that type of area mainly dealing with this type of deep learning. If the data is more, volume and complexity of data is high, and if you want to process the data with the help of GPU, then only you need to move with deep learning. If some very less amount of numerical information is there, there is no need of using deep learning concept. That was the previous conclusion of the previous step, right? So small size data is there, only you can go to this machine learning concept. The image data, the bulk amount of data, complex data is there, you can check with this data, the deep learning concept. So we are training images in traditional approach also. The previous example also ma'am was explaining with image, cat image and all, right? So here also that is possible. What will happening in traditional image, that with the machine learning technique, we will get a training image. That image feature we are taking, okay, not directly giving the images. We are taking the image features, then the classification, training, everything is happening. Then we are giving a testing image. For that testing image that we can't give directly, we are taking the features of that image, then only we are predicting. So this also happened in traditional process. That means image analysis only. Okay, so you can understand there is a specific area for extracting the images. Okay, so the image feature extracting, that we are converting to some pixel representation or numerical representation, then only we are applying. That was there. But if I'm extracting features, so many layers we can extract the features. First layer extraction will be the second layer extraction will be the third layer extraction, then only I can give to the training model. So that was there. But if yeah, you can see here how the different layers of extraction for one input image. Okay, first level will be like pixels, second layer it identify its edges, third layer what is the object part, and the next layer identifying the object. So feature representation is moving with so many levels or so many layers. Okay, so if we are going with a traditional approach, traditional image processing analysis with machine learning, we need to extract the image separately in a deep sense. Okay, so we can use now deep neural network or deep learning concept, convolutional neural network concept, all these things. So many architectures are there. I will explain the different architectures, but the image processing we can handle easily with this type of image classification problems we can handle with convolutional neural network, right? That's why I'm telling what is the limitation of traditional and what will be the happening in deep learning for the image processing. So if you are going with any machine learning algorithm, ML system, you need to extract the features, then only you can train. But if you are going with a deep learning, there is no need of separate feature extraction. Automatic feature extraction is happening inside deep learning because of these many layers, and classification also happening inside. Hope it's clear. So that is the main difference comparing machine learning and deep learning. If you are giving an image, the traditional system will extracting the features and everything, then only it moving for classification. All these things are happening inside deep learning. then we can easily find the output using any convolutional neural network. I hope it's clear to the audience, right? So all this happened because of dimensionality. That means number of dimensions in the data is high. That's why we have using this type of technique. Images are there, audio, video files are there. Yeah. If it is not, yeah. Can you please mute your, yeah, fine. So this type of issues are there. Then we move with the concept deep learning, mainly because of this feature extraction plus classification is happening in deep learning, and the curse of dimensionality. It can handle number of dimensions in the data. Okay, so that was the use of deep learning. That was the application area of deep learning. Okay, yeah, from this picture also you can understand what is the difference between deep learning and machine learning. We can give a cat image, as mentioned by the previous session. You can give image, but manually you need to extract the features, then only we can apply the machine learning algorithm. But if you are giving a picture in neural net, that deep learning, what will happen? If the layers learn the features, then it will give you the result. That means coming under convolutional neural network. So this is the scenario. A number of layers are high in the concept, right? The impact application we will discuss tomorrow. Okay, we can discuss and detail about deep learning applications and that related things, right? So why this concept deep learning is successful? Again, I'm telling increased availability of data, then significant improvement in computing power, increased model size, new way of learning representation. I told the word automatic feature extraction. Then it can generalize well. If one information is there, it is applicable to any set of data, any test cases, then that network architecture will be good, right? So these are the main reasons for successfulness of this deep learning area. Yeah. So again, I'm telling, if you are going with any deep learning, these are the main ingredients. You need to understand ANN clearly. You have the dimensional, because that high amount of data is required, then particular algorithm is required, deep learning algorithm, and computing resources should be there. So for this session, I'm telling about different algorithms in deep learning. Okay, if you are anyone is interested to move with deep learning, be sure about you are knowledgeable in ANN. Then be sure about you have that much data to process. Be sure about your system, that computing resources are there. Okay, then you can study any algorithm in deep learning. Okay, how to train this deep learning algorithms. Okay, so I'm just going with the different applications of this deep learning. You can, now onwards, from now I'm discussing about different algorithms. So you need to understand different application areas of deep learning. You classify images. This first problem, right? Then you can classify and localize that image. Okay, you can detect the object from an image. You can segment the images. So these are coming under computer vision task. Okay, so definitely images is there. The main property in that algorithm is images. So if you want to perform all these type of tasks, definitely data is high. Okay, so you can move with deep learning algorithm. So these are coming under computer vision task. Classification, image classification, image object detection, segmentation, all these are coming under computer vision task that we can do with deep learning algorithm. So many algorithms are available. That algorithm we are using for this type of application. Okay. So any computer vision task using deep learning, if you are going to do, you need to understand image. Previously, I told what? If you want to move with deep learning, you should have thorough knowledge of neural network. Then again, I'm telling, if you are moving with computer vision, deep learning using deep learning for computer vision, then you need to understand the image concept, the fundamentals of an image. Okay, that you need to understand. How we are representing image, it's something like one-way conversation. Can we interact something? How we are representing an image?
Ma'am, image is basically we have like grid structure and we have XY coordinates with the intensity of color of
Yeah,
that particular set.
yeah, pixel representations, right? Yeah, correct.
Yes.
That's correct answer. Each pixel XY coordinates will be the intensity based on that only. That values are changing. Yeah, so that is purely different. Black and white images will be the gray images, will be the colored images. Depending on it will change. So I'm moving to my PP presentation. Yeah. So for that, when we are going with an image, you can easily understand that image is representing with the pixel. Okay, I'm not discussing all these things. I will share all the materials. Okay. If you are going with any picture, the representation with some examples or some, you can see the some portion of that picture representation. Some repetitions are there. Some null values are there. Anyway, it's a representation perfectly with pixel information. Information based on the intensity of the value. Some missing informations are there. All these have some reason. Okay, so you need to get thorough knowledge regarding computer images. You can see here image here. Yeah, some image that is something like 8. Okay, 8 is the, okay, that is particularly that 8 value that is in color picture, but converting that into image of black and white. Okay, that image portion is representing with these much pictures. This is the way a computer sees an image. We are seeing in different manner. We are seeing in different manner, but the computer sees the image in this form. The pixel intensity, all these things it matters. Okay, if we are going with colored image also, mainly color image means RGB combination. That dog image you can see red, green, blue, right? So each combination has different set of metrics of pixel. Okay, so that combination of values. So I'm suggesting you to study the computer image related things before going with any computer vision task. Okay, if you are presenting somewhere, if you are discussing with your students also, you have the knowledge, right, what is behind happening with computer images. Okay, how the representation is come. All these things should be clear. Then you can move with computer vision task easily. I'm not explaining everything. You can see that image and the portion of that image, the tip of that image, if I am taking so many combination of values are RGB combinations are. Definitely, you can easily understand. Definitely, it will be like that. So combination, based on the combination, the metrics will be there. Yeah. So if you are building a process in more that deep learning, mainly for this classification and deep prediction purpose, we can use a concept called convolutional neural network. Okay. The method first I'm discussing here is convolutional neural network. Other than that, so many methods are there: recurrent neural network, generative adversarial neural network, autoencoders, transformers. All these things are attention mechanism. You are familiar. I hope some of you heard that words. Anyway, I'm starting with convolutional neural network, and we'll discuss RNN, GAN, auto, step one by one. We will discuss. Okay. So earlier era also the data set handwritten words, handwritten digit, that classification problems was there with simple FNN. What is FNN? Feed forward neural network. That concept I told you. The traditional method images are handling with traditional neural network. That was there. The next concept come in picture with the help of convolutional neural network. So we are going to start with convolutional neural network, but I want to show you the scenarios, different varieties of structures that we are using for all category. Convolutional neural network, the very first picture, this one is convolutional neural network. Then you can see here different scenario. So the first one is the feed forward network. Second one, you can see some number of convolutional layers. Then the generative phases, GAN architecture. Then so many other methods are autoencoders and every RNN method you can see here. So all are different in architecture. So we are going to discuss one by one. Okay, so first we are starting. We need to. I'm not discussing feed forward network. I know all of you are familiar with the neural network concept. Same concept with more number of layers. That is feed forward network. Input layer, output layer, and number of hidden layers will be high. That is the scenario behind which concept that feed forward network. So I'm moving to the concept called convolutional neural network. these things I'm going to skip this part. Yeah. So I'm telling about convolutional neural network for image classification. Okay, convolutional neural network method for image classification. For this scenario, I will tell one example illustration. Then I'm coming to the theory part. This is the methodology I'm opting for this theory class, for any theory class of a convolutional network. Okay, is it okay? Can I start with an illustration? Then I will move to the theory things. Is it fine? Yeah. So
Yeah.
Yeah.
Fine.
Fine. Yeah. So I'm moving. I will come to all the theory things, and before that, I will tell you one illustration. Okay. Yeah. Here I'm telling about one example. Something like tic-tac-toe game. You know, right? If I am putting 0, one can put cross mark, and again 0. If it is coming diagonal, what will happen? That person wins, right? Okay, and that second person will win, right? So that is the scenario. If I am seeing this picture in computer, 0 will look like this image. X will be looking like this one. O and X, not 0. O and X. Imagine black and white image. I'm not discussing about color image. If I want to explain in detail, I can use only black and white. Okay, RGB combination is more tough, right? So I'm explaining convolutional neural net with this example. You can see here S0 is representing like O is representing like this, and X is like this. Yeah, very similar to O and X. Why I'm using this picture? I want to tell you these all are pixels. Pixel representation for O and X. Okay, so if I am taking a picture and if it is 0 and X, easily you can translate like this. Where the black points are there, that we can assign as 1, and where the white spaces are there, that we can replace with 0. In X case also, same. Can you please mute? Yeah. Yeah. So that O and X is the audience. Please mute yourself. Yeah. So X is the X also I'm representing with 0 and 1 combination. This is a pure black and white image. Okay. So yeah, what is the size of our entire picture? 6 by 6. Is it so? 6 by 6. Yeah, 6 by 6. So this much information is there in the picture, right? If I am going with a neural network, the first neural network I told you, feed forward neural network concept, I want to represent this pixel in my input layer. If I am representing input layer with this much pixels, 6 into 6, 36 values I need to represent. This is the scenario. 36 inputs are there. Then that 36 inputs I am giving to neurons, like to perform what are the operation input into W1, X1 into W1, X2 into W2, X3 into W3. That operation we need to perform. So you can imagine how much weight I need to assign here. Then here also, if I am using 2 neurons, again, I want to use so many weights. So X is this one, 0, 0, 0, and weights are there in the links. Then I am producing some summation operation X1 plus X1 W1 plus X2 W2, etc. Then bias will add to that. Then I will apply some activation function. This is a scenario we need to follow if I am using a feed forward network, right? But so that this is a very tough task. You can imagine how many the number of weights we need to use to handle this much weights is tough task. If any sharing is there, if any sharing of weights is there, that will be good, right? So here there is no possibility of sharing. Each and every unit of inputs is using separate weights. So heavy task. The way of handling this type of information is heavy task, right? Then in neural network, if I am shifting one pixel and the image is shifting to some portion and it is showing like O, but the system will not predict it is O. Why? Some mistakes is there. If our system is handling this type of images also perfectly as O, that will be good. Okay, so that is not possible with feed forward network. Okay, minute changes has happened, and that is also rectifying, identifying as perfect and perfectly with answer output, predicted output, then that will be good. So this type of scenario also we need to handle. In neural network, it's not clear that neural network will recognize this as O. Okay, it will predict it is wrong answer, but it is some shift in the pixel only. Okay, so this type of scenario also we need to handle. Then you can check this picture. Yeah, each and every portion of this image is complex. So this type of complicated images, if you want to handle, that is also possible, not possible with neural network or feed forward network. So that is why we enter into convolutional neural network. Again, I'm coming to my point. Okay. Yeah. So how I can apply this neural network and how I can this convolutional neural network help you to solve this type of problems. Okay. I'm starting with an idea called filter. Okay, if you are giving input image in a neural network, you have to set a filter. For convolutional neural network, we need to set a filter first, then only you can move. Okay, the filter value selection is a tedious task that is performing with the help of backpropagation algorithm. You know backpropagation, what is happening in backpropagation. If it is not matching, again changing, that much operations are happened, and we fixed a filter for our algorithm. The filter is sometimes known as kernel fixing is heavy task. Once fixed, we can use with your algorithm. Okay, a filter is here is a small square, that is 3 by 3 square. Okay, the values, after all analysis only we can select this type of values. Commonly we are applying the backpropagation method for analyzing. Separate task, filter selection. Okay, that was there. Okay, then here I selected that 0, 0, 1, 0, 1, 0, 1, 0, 0. This is selecting based on your data only. Okay, this filter is selecting based on data with proper algorithm. Okay, then I can apply this filter on input image. Which image? Our image is O with a black and white combination. So I'm applying that filter to my data. This is my filter 0, 0, 1, 0, 1, 0, 1, 0, 0. So this I can fix with the first combination of my portion of my data image. What is my first portion? This is my version 0, 0, 1, 0, 1, 0, 1, 0, 0. That first 3 by 3. Okay, the first 3 by 3 is that I am using convolution concept for convoluting the data. Okay, how I am convoluting the process is like our portion of image is multiplying with the filter value and performing summation on this data. You can easily understand the value we are getting after convolution. 0 into 0 plus 0 into 0 plus 1 into 1 plus again second row 0 into 0 plus 1 into 1 plus 0 into 0 again third row 1 into 1 plus 0 into 0 plus 0 into 0. You will get a value like 3. Okay, so that is the representation. Convolution happened with the help of this filter. Okay, that is the first stage. Again, we need to slightly change the position. What will happen after changing? Wait. Yeah, what will happen after changing? One little one shift only happened that we can use like equation. You will get 0 into 0 plus 1 into 0 plus 1 into 1 plus 1 into 0, and again we are multiplying all these things, right? Is it possible for how many times it is possible? Can you just for this picture how many this type of calculation is possible? Just message me or you can unmute and type. How many for this picture only? For this picture, how many that convolutions are possible? One I showed this one. One again one change will be there. Again one change is possible. Again one change is possible, right? How many changes are possible? How many convolutions are possible? Can you guess? Some answers are there, right? I will show you. Yeah, it's something like I will show you this one. This method you can see 4 into 4. 4 into 4 calculations happen. 4 into 4. Okay, this many possibilities are there. 4 into 4, 16 possibilities are there. Okay, so how it is happening? First combination, you will get some result. What will the value of this one? 1 plus 1 plus 1, right? 3 you will get. That 3 will be there. Then that convoluted value adding with some bias. You can fix some bias based on your application. Here my application is to check whether this is O or X. Whether it's O or X. So I'm setting one bias value -2. Okay, for my problem. So 3 minus 2, my value is 1 for the first operation. Okay, so I am adding that value to feature map. So third word came. First, this one is input image. A filter is there. Based on the filter, I created one feature map. Fine. Yeah. So second step, again, I'm sliding some portions and I'm doing the same convolution. I got a value like 1 after convolution. Again, I'm using the same bias and putting the value in the feature map -1. I'm creating one feature map based on this convolution. I'm not repeating this one. Finally, you will get the values like 1, -1, -2, -1. One down shift is the -1, -2, -1, -2. Again, one more shift, -2, -1, -2, -1. Then entire portion we covered. We can cover the entire area and you can create this feature map. Okay, so once you get the feature map, what is your duty? So image, filtering, after that we apply the feature map, convolution, feature map. Okay, so after convolution you get a feature map. There you need to apply a well-known activation function called ReLU activation function. It is very common for convolution neural network. ReLU, you can apply any algorithm, but that ReLU help you to support the non-linearity. If in your data non-linear feature is there, ReLU is a good one for handling the non-linearity. So this is a ReLU function. I don't know how many of you are familiar with that ReLU activation function. Very simple activation function. If you are putting some input set to activation function ReLU, it will generate max of 0 set. I'm giving input set to ReLU. It will produce the output max of 0 set. That means if I am giving an input set equal to 1, max of 0, 1, 1 will be the output. If I am giving a set is equal to -1, max of 0, -1, 0 will be the output. Hope you can understand that scenario. That is the ReLU activation function. Whatever thing is given as input, that is comparing with 0, and 0 is, if it is maximum, then that if it is above 0, that will be displayed. If it is below 0, 0 will be displayed. That is the ReLU activation function. It is something representing like separate lines, piece of lines. So it's coming under piecewise activation functions. Okay. Anyway, this is feature map. I am applying ReLU here. You can easily understand. If I am giving 1 to ReLU, it will reply 1. Right. You can see here. If I am giving -1 to ReLU, definitely it will show 0. If I am giving -2, it will show 0. Again -1, 0. Then the second row, everything is negative, 0, 0, 0. Only the value I have obtained is 1 is the last position. Okay. So this is a feature map. We have applied ReLU on this one. Okay, ReLU activation function. That is happening. After ReLU, what we need to do? We need to perform an operation called pooling. So we can set the things for pooling. Here I am pooling based on 2 by 2 grid. So entire feature map I am dividing to 2 by 2 grids. Okay, from each grid I am taking the maximum value. Then that pooling is known as max pooling. You can see here from this area 1, 0, 0. I am taking 1, 0, 0, 0, 0. And here 0, 0, 0 is there 0. 0, 0, 0, 1 is there 1. So this process is known as max pooling. If I am taking average of this 2 by 2 grid, then that is known as average pooling. So different pooling scenarios are there that you can apply and you will get 1, 0, 0, 1. Okay, and then my pooling is over. Next duty of mine is to represent that pooling. This is the representation for mean pooling, average pooling. For this application, 0 or X identification, I am using only what I'm using here only max pooling. So you can see this is the result of max pooling. 1, 0, 0, right? Max pooling. From where we start,
image where we took convolution, that bias applied, feature map created, ReLU applied, and we got one result like this. From that, I am applying max pool. This 1001 I am applying to my feed forward neural network. 1001. 1001 I am applying to my neural network, feed forward neural network. This process 1001 putting in one row, like one set of neurons, is known as flattening. Initially 1001 is in matrix format. Then now we are giving as input to neural network 1001. Then this process is known as flattening. Okay, can you imagine what is happened here? If I am using directly the input image to feed forwarding network, I told you 6 into 6, 36 input I need to give. Can you guess how many input I am giving to neural network? Just message me, or you can unmute and tell. How many inputs I am giving to neural network instead of 36? I want your reply. Yeah, 4. Why I'm asking reply in between, I need to, 4. I need to understand whether you are following or not. That's why I'm in between, I'm asking. Anyway, yeah, fine. So it's good there, you are responding, right? So 1001 is the input I'm giving. So that first problem I can eliminate. This problem, number of dimensions we are applying to input layer. So here I am sharing the weights with 1001 only. Then next process is very simple. You can apply your feed forward network. Whatever input is coming from here is multiplying with some weight. You can see here some weight that I'm prefixed ones. Why it is so? I need to solve this problem, O or X. So these are the predefined weights. Okay, so some weights are there. I can sum up like 1 into 0.80 into minus 0.7. These things I can perform. Bias I can add. Then again I am applying ReLU. All these things happened, and I got a result like plus 1.45 is added, that bias in the output layer. I got a result like 1 here and 0 here. 2 output neurons are there. One is producing 1, again is second one is producing 0. First output neuron is representing O, second output neuron is representing X. Can you guess what is the result of this entire task? I got a result in output layer setting for O as 1. What will be the result? It is predicting this picture as predicting as
1.
Is it X? 1 is there. 1 is representing what? 1 is representing this neuron. Output neuron is representing Oh, yeah. That value came O neuron only came with 1. Then that will be printing as the picture is representing O. Some questions are there like how we are setting this weight. Purely it's based on that regularization operation. Okay. So we need to add all these things, and we need to change the parameters. Based on that only we will finalize this one. This is for your understanding. Fixing the correct values. For your explanation only I'm fixing. It is not possible in real-time scenario. For this example only I'm fixing all these weights for your understanding. If you are going with real-time, that tuning is required, regularization is required. All these things are required to improve your model performance. You can regularize with changing the weights. You are regularizing with some norm penalties. You are regularizing with so many methods are there. Adding constraints on your model. Based on that only your model will be good. Here I am setting the weights for your understanding purpose, right? Yeah. So it is predicting as 1 in that neuron, output neuron fixed for O. So easily this setting is okay with O. Then definitely you will have doubt whether I am giving X in the same weights, it will predict, right? Will it predict is a question, right? So you can see here, same setting. I'm giving the input image as X. I'm giving the input image as X, and the convolution, same convolution filter, same filter. There is no difference in the filter. That same procedure is happened. Then some packs pooling happened. Different values there to, different 4 values are there to represent 0, 1, 1, 0. Then I applied all this method. Then you can see where we get the value 1. Which place I got the value 1? It is with X or O. 1 is there with X, right? So easily from this setting help you to predict O and X. My motive is to tell, because of this concept, convolution and everything, it will reach to a shared process called 0, 1, 1, 1, 1, 0. This again, once you got this value, flattened value, you can move with any feed-forward neural network. Okay, you can move with any feed-forward network for prediction. Hope it's clear. Is it okay for you? Yeah, X answer is there. I didn't see. Okay, anyway, fine. Okay, yeah. So it's clear. Then I told you one more point. If any slight change or any slight changes happen with image, from your viewpoint, you can understand this is the picture of X. But the point of computer vision, it's not perfect X, or the system need to understand this is X, right? So same setting is applied with same weight value and everything. Then you can see what I got in 2 neurons. One neuron is I got minus 0.2. Then another neuron 1.23. But it's close to X. So it will predicting that image is close to X. So slight changes is there in picture also, it can handle convolution image with the help of all this procedure. So this is the convolutional neural network. So I hope this illustration is clear. Then I can move with the theory. If we are going with convolutional neural network, use parameter sharing. Now you can easily understand where the parameter sharing happened. Where the parameter sharing happened. Can you tell? Yeah, I will. How we get minus 0.2? Based on the calculation, you can check that minus 0.2 is because of that all calculation. Okay. Yeah. That bias is there to fix everything is there. Okay, this is a simple example only. Based on all the calculation, you will get minus 0.2. I will share all this material. You can check it out, work it out. Based on the current setting, you will get minus 0.2. Yeah, my question is for the convolution neural network, the first statement is use parameter sharing. Which parameter I'm sharing? Can you tell? Yeah, which parameter we are sharing? No, I told you one parameter is reduced. Some extent we can reduce. Which one?
Weight we can share.
Yeah, that weight value, you can understand that 30 to 36 weight I'm converting to that one. So that is the point here. Yeah, that is the point here. Convolution neural network use parameter sharing. Then filters are there to convolute the image. That now clear. We are using filters to convolve the data. Then these filters, I told you, some methods are there to training that filters. Okay, based on the training only we are setting the filters. Then next everything will happen like fully connected layers. Okay, somewhere we will use normalization also. Okay, normalization is happening to adjust the variance and everything with the then so I'm not explaining what is happening in convolution. You are now clear about convolution. In theory part, so many things are there, what is happening with convolution and all, but I want to tell you what is entire things happening with. Yeah, you can see here, if I am giving a picture, I need to perform convolution. Then after convolution, I need to perform pooling, but it will not stop there. Again, I can do the convolution on that same pooling data, then again pooling. It can repeat many times. It can repeat many times and wait, what will happening after all this thing? Flattening. Once flattening happen, you can give it to fully connected. This is the entire CNN architecture. Image, you're performing. Now you are familiar, convolution. That layer is known as convolution layer. Then pooling, that pooling layer. Then again, if you want to perform convolution, everything you can apply. Then flattening that information received, and we are giving to fully connected data. In between, there is a chance of adding one more layer, that is normalization layer. If you want to change some parameter in a uniform format or a variance, we need to say That also we can add in your architecture. That layer is known as normalization. This is the basic idea of CNN architecture. So, yeah, all these things. What is flattening? Everything, I hope it's clear to you. Yeah, pooling layer. It's clear, right? This layer is pooling. It's clear, right? Maximum pooling, average pooling. That thing is clear, right? Yeah. The very first CNN model was this layer architecture. Okay, that models and architecture only I need to discuss, right? So CNN model is very first model is this layer architecture introduced by Lakian in 1989. Yeah, that was the but it is not perfectly for deep learning purpose. I told you 2006 onwards that is deep learning things will be there. Okay, this was all the mathematical tricks are there in history, right? But in not in programming mode. Okay, not like this type of technology, TensorFlow, PyTorch, all these scenarios are not right. Anyway, yeah, input image is there. We are applying convolutions. So convolution layer, creating feature map. If you want to reduce the size, we can apply subsampling layers. Again, convolution, then subsampling. After all these things only, we can apply to full connection. Fully connected network also, a number of fully connected networks are there. Okay, so these type of ideas we are incorporated with CNN layer. Okay, all the convolutions, how many convolutions are happening, all these things are there, right? Then AlexNet, that also part of deep learning. ImageNet data is the ImageNet data, readily available data that is checked with AlexNet and all. That also architecture of also different. Our image you will take, one convolution will happen. Again, max pooling is happen, normalization is happened on the data. Again, convolution will happen, max pooling happen, normalization. Again, 3 more convolution, max pooling, then fully connected layer 1, 6, 7, 8, 3 fully connected layer. Can you imagine how complex this picture? Because the image data is that much complex. Okay, if that data is complex, we need to add more layers. By illustration, you can easily understand what are things happening. Okay, very simple picture, and that picture is handling this much data. Okay, that is very easy task. But the image perspective, that complexity of image is very high. So we need to go with more architectures. Okay, so many CNN architecture are there: AlexNet, VGG, GoogleNet, ResNet, DenseNet, so many mobile net, so many application. How we are using these things in application area, that we will discuss tomorrow. But you need to understand, if we are going with AlexNet, 8 layers are there. VGG 16 to 19 different layers are there. GoogleNet 22 layers. ResNet 152 layers. Okay, the performance of ResNet is very high compared with other models. In each era, 2020, 12, 2014, 2014, you can see the advances in each year. Right? So with VGG architecture, you can see one image and how the layers are going. Okay, the image itself, it's performing so many operations and moving with all these layers. Yeah, GoogleNet, I'll show you the picture. Yeah, wait. I will show you the picture of GoogleNet. Yeah, simply this type of example, how you can imagine with one picture. You can see one picture here. It's a truck. Okay, it's a truck. Once the convolution happen, image will be like this, first layer. Then we apply ReLU here. Well, that means that pooling and everything, right? So here it will be like this. Again convolution, then ReLU, pooling, convolution, ReLU, convolution, ReLU, pooling, convolution. Finally, fully connected layer, it is predicting it is a truck. All the combinations are there. Car is compared with the truck. Car is less. Airplane, ship, horse, everything is less, right? So we can identify that it's a truck. Hope you can understand the layers we are applying in each base. Same scenario is happening here also. You can understand the values I am getting for that picture is something from image, convolution, max pooling, convolution with 64. What that 64 means, that filter size. Okay, filter size we are applying. The image size for banana is 224 into 224 into 3. For that data, I'm using a convolution of 64 filter map. Okay, that applying, and then max pooling. Again, the filter is changed 128. Then again, you can understand how many layers I am applying. All this, after all these things, I am getting the cat neuron as 0.2, dog as 0.4, chair as 0.09, bagel as 0.01, and banana as 0.3. That's minor difference. Then I can understand that banana 0.3. This is only for one banana. You need to give it so many banana pictures and accuracy need to be high. Then only we can fix that diagram, that model. Okay, so that is the things happening with all these things. Then VGG16, Google Net, all these things are pre-trained models. Okay, pre-trained models are readily available. You can readily use. Nowadays, there is nothing to follow with this type of layers and everything. All are in package mode. If you want AlexNet, you can readily available. VGG16, that is readily available. Google Net, readily available. All these things are pre-trained models that we can easily use for deep learning concept. VGG itself, so many versions are there. Okay, already tested with ImageNet, then only they release this type of product. Okay, then likewise ResNet is there. ResNet means CNN plus some skip connections are there. You can see in that picture. From one point it is skipping to somewhere. Shortcut connections are there. That is the specialty of ResNet. Same the idea we are following, different layers are there, but in between some skip connections are there. That is ResNet architecture. Okay, likewise dense net is there. Okay, a deep dense net. Dense, the word it means some dense blocks will be there. Okay, that only predicting the horse as horse itself. Okay, so some dense blocks are there, more layers are there. That's based on that we are predicting. Okay, so when we are going with this type, all are related with CNN. All these models are related with CNN. Okay, different versions of convolution layer, setting of convolution layer and everything. But when we moving with this depth concept, that means deep learning concept, we have to face overfitting. Okay, that vanishing gradient, we are using ReLU activation function. So somewhere the vanishing gradient, ReLU, somewhere it will act, dou by dou x and everything we are taking, some point will miss out. Batch normalization, we have group of normalized layers are there. So it's accelerating train. Hyperparameter tuning is required. All these are challenges, but we need to face the challenges with proper technologies. Dropout is there in between that affecting overfitting. Okay, so challenges will be there that you need to identify, and proper method you have to check with your data with CNN, any versions of CNN. I hope this CNN concept is clear. All these type of different method, dense net, all these things are the CNN. If once you study the basic idea of CNN, you can easily understand all this method. Hope it's clear. Anybody has any doubt regarding CNN? How to apply in any clinical data set, whether this data set is image or numerical information. Just applying clinical data set with numerical information, you can use any numerical. If it is numerical, you can use any machine learning algorithm. And it's not required to go with deep learning. Then, if it is huge amount of numerical data, it is tough to handle with any machine learning algorithm, then only you need to move with deep learning. Yeah, hope it's clear that CNN and everything. Okay, so I'm going to discuss about the next methods in deep learning. Okay, so different other architectures are there. I told you CNN is very base only. Then RNN, LSTM, stacked and autoencoders, GAN. Then combining all these architectures also there. Okay, have you heard this words TensorFlow and PyTorch? You can just search it on. Tomorrow we will do some experiments. This one, CNN and everything, images, right? Okay, so RNN, recurrent neural network, long short-term memory, that LSTM neural network, all these are for sequence learning. If any particular sequence in your data, if you want to predict the next sequence, you can use this type of concept. If any representation learning is required, you can move autoencoders, encoding and decoding. That is happening in stacked data. Then GAN, perfect distribution learning, some distribution or some classification that is happening with GAN. I will tell you some theory regarding all these things. Some more concepts are there, transformers are there, all these things are there. I'm just explaining these methods for your understanding. Okay. First, I'm telling about autoencoders. Okay. That is also one of the method in deep learning. Okay, it's a special type of neural network where you can see the output layer has the same dimensionality of input layer. That picture it's visible, right? Whatever things we are giving in input as same as output layer, right? In between, very important things are happened. What was that? Encoding and decoding. Once you encode, you will get some coded information that we will need to decode. So encoders are used to reduce the size of our input to smaller representation with the help of encoding. Okay, then number of output unit is equal to input unit because of decoding. So autoencoder is a concept that replicates the data from the input to output in an unsupervised manner. There is nothing like classification in it. It's unsupervised, just clustering the information. Okay, so it is known as replicating the input to output, right? So it is known as replicator neural network. Yeah, once the picture is clear, you can understand what is happening in between. This is the architecture of autoencoder: input layers, encoder, code, decoder. Okay, what will happen here? Bottleneck is in the hidden layer. Hidden layers only we need to bother. Okay, input layer and output layer already fixed. Okay, so it's data specific and there is a chance of lossy. Then here, what are the parameters need to be understood? Size of code. In the middle portion, code, which size we need to encode. From that only we need to decode, right? So code size we need to understand. Number of layers, it's a very huge task to set the number of layers. Number of nodes or number of neurons per layer. Which loss function? For every algorithm, you have to check with the loss function. If it is CNN also, how we are checking the accuracy? Banana we are giving. If it is predicting banana as banana, then there is no issue, no error. If banana is predicting as cat, that is not good. How many bananas is predicted as cat? That we need to check and find the loss function. That is the method only for identifying the error and accuracy of the model. So here also, we can see these are the main parameters for autoencoders. So that area you can use for image coloring. Same input as output, right? Same bench in the bench image and same output as bench image. But what happened in between? Can you guess? First image is there. Last image is what? Colored image, right? So input and output are same, but something is happened in between, right? So you can see a feature variation. Feature variation. One image is there as input. You can see that is slightly, it's not in straight position, there's slanting position, and some white light image is also there, right? Same picture is happened as output image. What is the specialty of that image? Feature variation. Some features we varied, right? So these things are possible. This type of application, image coloring, feature variation. Input is same as output. That's no deviation, but some encoding and decoding is happening. This type of problem we can solve with autoencoders. Am I clear? Is it boring? No, no one is responding. Yeah, fine, clear. Yeah. So yeah, fine. Yeah. So image coloring, feature variation, all these things are possible with this autoencoder concept. And then other thing, dimensionality reduction. You can see the first original image is like it's 1000 KB size. That I changed to 25 KB. Picture is same, the same picture, but the clarity is good. Then some dimensionality reductions are happened. Okay, so that also happening with the help of autoencoder. Then one more very important concept application of this autoencoder is that denoising image. That image is a noisy image too, handwritten image too. That is noisy image. We are denoising. Okay, what are the procedures that happened in encoder, decoder? That is very important. Okay, so that is these are the application. One more application I can tell you. If removing the watermark. If same images as output, but what happened? That watermark is removed. Okay, so how it is happening? What are the different autoencoders for this process? The simplest encoder is under complete autoencoder. Okay, it uses a single multiple hidden layer that has smaller dimensionality than the input layer. Okay, a single dimension hidden layer we are using. Here the task is not to set input layer or output layer. The task is to set the hidden layer. Here how we are setting the hidden layer? Smaller dimensionality than the input layer. This forces the network to learn a compressed representation. You can see here H is equal to hidden layer, here W expand bias. W is the weight of the encoder layer, bias is the B1 is the bias of the encoder. Then we apply G, activation function on that the hidden layer with weights and all. Next, weight from hidden layer to output layer. Very simple, but here what we need to set, we need to set the hidden layer as a smaller dimensionality than the input layer. Yeah, fine. So you can see in this picture also, input layer contains 6. The hidden layer is input and output is 6. Hidden layer is 3. Okay, so this undercomplete autoencoder is giving a compressed representation in the encoder side. That compressed representation is decoding in the decoder side. Okay, so number of by say bottleneck. There are also bottleneck. It's a simplest form of autoencoder. They prevent the network from simply memorizing the training data. Instead, encourage to learn meaningful representation. The meaning is this one only. The input layer is large. We are representing in a compressed format to memorize the things very easily. Simple autoencoder. Then sparse encoders that you can see here. So many sparsities there. Input and output layers are same, but we are applying some encoding and decoding with more number of layers. Okay, sparse encoder built upon the concept of the same undercomplete autoencoder but here introducing a constraint known as sparsity. Same algorithm and everything. Here we are introducing a sparsity. Okay, because of that, here it enforces to only a small portion of a neuron, the hidden layer, are active during the train. Okay, some is sparse. That means here you can see in the picture. Some is vacant. That means hidden layer. I am telling at a time some neurons are active, some are not active. Likewise, some setting is happening for encoding. Then it will produce the decoder result. Okay, same as you can see the blue first layer, 4 only active. Then hidden layer 2 only active. Anyway, it is less compared with hidden input layer and output layer. So that setting of how which one is active and which one is deactive, that is the specialty of sparsity or sparse autoencoders. Then another way of representing autoencoder is contractive autoencoders. Okay, that focus on learning, more compact representation of that. Okay, how the learning is happening. That means how we can add different regularization. That means regularization, you can understand, is a term to avoid this type of overfitting and underfitting. That means if you are changing anything, that will not reach to overfitting and underfitting. Oh, wait a second. Yeah. Is that time to wind up? Sir, can you respond?
Yeah, ma'am. Now it's 9 p.m.
Yeah, fine. Yeah.
Mm.
I started with the 7:45.
Yeah,
Right?
yeah.
Yeah. I will wind up within 5 minutes or 10 minutes. I will take. Okay.
Okay.
Yeah. So this type of different styles of autoencoders are the. I told you denoising is also possible. That type of encoders are known as denoising autoencoder. There also we can apply that type of convolution technique. Okay. So I'm skipping all this part of how we are applying autoencoders. Then GAN is there. Have you heard this word? Generative Adversarial Network. GAN. Okay. It's a very big topic. Okay. Yeah. So just I'm introducing this generative adversarial network. You can see 2 imaginary celebrities that were dreamed up by random number generator. From some random concept of the coding, you can create some pictures and everything, right? So generative modeling is an unsupervised learning approach. This model can use to generate new examples. That is the policy. Okay, generate new example. That is not in their end, not in our hand, not in some other's data set, but we can generate new examples from the original data. So it's why it is generative adversarial network? To learn a generative model which describe how data is generated in terms of probabilities model. Adversarial means training of a model is done in adversarial setting. Some settings will be network, use deep neural network for training purpose. That is why it is generative adversarial network to learn a generative model. Generating means generating a new example from original data set. Okay, so main two terms coming under generative adversarial network is generator and discriminator, like encoder and decoder and the autoencoder. Generator trying to generate new data set. Okay, discriminator, it compare those images with real world example and classify whether it is real or fake. Okay, so generator and discriminator are the two words. So for doing GAN, you should have real world images and you can use a random variable to generate the image, and discriminator will check whether it is real or fake based on the loss function and everything. So that is the policy. So many things are there with the GAN architecture, how it is happening with real data and fake data. Anyway, tomorrow we will explain the application of this GAN. Okay, likewise, one area is there for this type of deep learning things. So many algorithms are coming under object detection. Okay, CNN is mainly for classification. Autoencoders, you can see it's mainly for that representation learning. Then you can see RNN will be there, that is sequence learning. Then that this type of algorithms, generative AN is there, that is the discrimination. Likewise, object detection algorithms are. Okay, object detection mainly for detecting the object from a particular scenario or a particular picture. Okay, that is happening with the help of segmentation. In segmentation is possible to detect the things. So for that, that image representation we can use with some sliding window algorithm. All are representing in grid pixel format. So we apply this type of convolutions and everything with sliding window algorithm. You can see here the image is divided into different slides and we are identifying the car and vehicles from that image area. Yeah, so how we need to detect these positions and how we are checking whether it is accurate or everything. That is with the help of probability score. Okay, a bounding box we need to check. Okay, IOU is there to describe the overlap of two boxes. Okay, so ground truth will be there. Okay, then we need to check with our assumption. So then these two bounding boxes are correct, then it will be good. So for that we are using intersection of our. You can see here how we are creating a bounding box. Okay, so the bounding boxes are very important for any object detection algorithm. So then we are identifying that is with this one, I can say 0.9%. This is car and everything. So I am skipping all this portion that I am is going. Yeah, yeah. So for that also we have different algorithms that have you learned about that algorithm YOLO? Heard about that algorithm YOLO? That is very famous algorithm in the category of object detection. Anyway, I will do one thing. These things can explain with the application in the next session. Is it fine, sir?
Ma'am, transformer.
Yeah, we'll discuss tomorrow, transformer and attention. Yeah, that with the application we will discuss. Okay. Anyway, you can ask any doubt or whatever things are you are expecting for the tomorrow's class. Also, you can suggest. Yeah, that last class, ma'am also told that Andrew NG classes are very good for any deep learning application. Some topic related to binary. I missed out some questions. Can we discuss some topic related to binary and classification? Oh, deep learning, when we going through deep learning, it will be perfectly with images. Okay. Yeah, if you have any doubt that you can ask, all these things I will share. That is not a problem. Then what you are expecting for tomorrow also you can tell. What's my plan? All these things I can explain with the problem. That means application and some hands-on session I am planning. The transformer that I will add. Okay. Any doubt is there? You can ask. That's time. Yeah. Fine.
General doubt. If we compare these image processing with the help of these neural networks, artificial neural networks, and I mean, machine-based processing is this. If we compare this with human visual perception and interpretation, like in human's brain, I mean, light enters through eye, is focused on the retina, is converted into the electric signal basically by photoreceptor cells, and the signals are then sent to the brain by optic nerve, and then through visual cortex, the data interpretation, process there, and after that, we can identify the colors and depth and all. If we compare this human interpretation, data interpretation in the brain with this, what we are trying to mimic or with this artificial thing, which is more complex? What is your opinion on that?
You're telling about one is happening in the real scenario, and this one is happening in that machine learning part. That means
Yes.
deep learning part. Whether it is possible to compare, that you are asking, right?
Yes, which is more complex in Europe.
Yeah. Earlier days, I'm telling about before 2016 or somewhere. If I am telling to you, telling like robot can do the surgery, or if I am telling something related, that no one will suggest the robot, right? A doctor is the person to do the surgery, but now hospitals are doing robotic surgery, right? So the scenario, because of the technology advancement,
I was talking about complexity of the data processing, which is more complex. I mean, on the machine is complex, or in the human brain is more complex in the identifying the shapes and colors and that.
Definitely that all the human related things we cannot mimic. Okay, some extent we can do all these things with machines, right. So that is the thing. Complexity is based on the problem that you take. Okay, some problem machines can easily handle compared with our idea. Sensing capacity is different for different humans, right? Or any emotions we are taking, if it is different for different humans. Some problem specific, it should be coming under problem specific operations. Some problems the system is easily can handle. I will tell you the scenario, like if I am taking an X-ray image and identifying some taking that X-ray image and identifying that which portion is affected by any specific disease is tough for human. Like if I am not from a clinical background, it is tough to understand for my neural network in my brain, right? So if I have the perfect algorithm, deep learning, when I give that picture, it will easily recognize which part is affected. So that data is there. If it is with a clinical person, it might be easy. But if I am not a clinical person, that person can easily handle that scenario with the help of deep learning things. Case to case, it is varying. Hope it's clear.
Yeah. And human and making errors is the basic human nature. So that's also in it.
Yeah. Hope you can understand, right? Yeah. Any other queries?
Yes, ma'am. I have a query. I have a query that we have worked on machine learning for these image data sets. So I want in the deep learning session that will be coming up, we want to touch on that numeric data sets like binary classification or NRD classification, because these images and all are separate computer vision, and these all things are in this image processing thing. But if we want to go work with that textual data set or CSV file or something like that file, how can we handle that thing, and what are the models for that? That I want to request for touching on in the next session.
CSV file, if you have huge amount of data, that I'm again specifying huge amount of complex data is there, then only you need to go with this type of algorithm, deep learning algorithm. Otherwise, you can use a simple machine learning algorithm if you have a CSV file with numerical information.
No, yes, we have a huge amount of data that is in terabyte and
then I will tell you.
sort of thing.
I don't know
So case we have to use that only. And in that particular case, where I was stuck last time is that can we do incremental model training sort of thing? Because if we have trained on the data till 2022, then what about 23? It has to be a new model, which is the taking the previous inputs or what? Because incremental model training, because if we have 10 files, if the model has trained got on 1, 2, 3 files, but when the files coming on increasing 4, 5, 6, then how it will go for incremental model learning?
Yeah, all these things are applicable. Have you heard this word like LSTM? Or if you want a time series, like you mentioned, like next incremental approach or anything, time series data, then you can go with LSTM. In the weather forecasting, or rainfall prediction. This type of data contains only numerical data. Right, there is no image in that picture. Rainfall information, day by day information, everything is in numerical format only, but lakhs of or crores of data will be there. That type of data you can use LSTM. So many time series analysis are there in deep learning. That type of time series analysis you can apply on this type of data. One of the example is LSTM. You can advanced LSTM methods also there. Directly you can apply that.
Yes, ma'am. Correct, ma'am. So will we be taking in the next session some of the data from the Kaggle and doing that analysis?
Kaggle analysis, that type of data will not be there. For analysis, you must require that type of an amount of data. Anyway, I will add LSTM. I will try to add LSTM if time permits. Okay.
Yes, ma'am. Thank you, ma'am. Thank you,
And
ma'am.
then one more thing I want to add with that, if I am going with a text NLP related thing, that also there in deep learning. Here I am telling about computer vision part and different methods in that area. Okay, these are the starting for any deep learning concept. But if you want an NLP, BERT models are there. Some other deep learning methods are there for handling natural language processing. Google Translator, how it is translating the languages, right? So that is working in the NLP concept. That type of area is that for that also deep learning. So many algorithms are there. Okay, that is that you need to check it out. Okay, fine. Any other doubts?
Okay, ma'am. Thank you.
Yeah. Any other doubts? Or shall we wind up?
Ma'am?
Yeah.
Ma'am, when we given the maximum pooling after x minus 0.8, so what is the x minus 0.8? What is the value there, ma'am?
Not x, it's into multiplication.
Okay, then 0.8 means?
0. Is the weight value. I have fixed the weight value 0.8 for that that link.
Ma'am, I have question in perceptron. Why we take a bias unit in your perceptron neural network?
Bias for any neural network, why we are using bias? To get the control of the output. You need to get the control in your output. You can add the bias values, bias weight. If the control is required, only we are using bias. Then that when we can say it is, there is no overfitting and underfitting based on the bias and variance, right? So
then how much value is taken?
High bias with less variance, that will be good, right? Yeah. So the bias is mainly to control the output.
Okay.
Yeah. Soundaryavalli, I hope it's your. I hope I answered your query.
Yes, ma'am. Yes, ma'am. I understand.
Any other doubts? Or shall we?
For tomorrow session, we need a transformer.
A transformer, then LSTM, sentimental analysis. Yeah, I heard these words. Whatever thing is possible, I will add. Okay.
Okay.
Abhaya Jayakrishnan.
Yes, sir. Thank you, Dr. Suchitra, for sharing your knowledge with us today. Your session was truly insightful on neural networks and deep learning. You explained the topics like how neural networks design challenges, automatic feature extraction, auto encoder in a way that in a way it was very easy to understand. Your discussion on deep learning, computer vision, and how convolutional neural networks process images was very engaging and practical. This session has given us a clear understanding and inspired us to explore more. Thank you once again for sharing your knowledge. Your feedback is very important to us. We have shared the feedback form in the chat and in the WhatsApp group. Please take few moments to fill it out as it is essential for marking your attendance. Please note that the participation ID has been published in the WhatsApp group.
Okay, thank you all. I'm leaving, sir. Thank you. Good night.
Thank you, ma'am. Thank you. Good night.
Thank you, participants, for your active participation. Thank you. Good night.